And welcome everyone to our fall meeting of the FCC Technological Advisory Council. And we are seeing a number of people join exactly at the hour. So
Thank you.
we'll give them all an additional welcome, and welcome to those of you who are tuning in via the internet. We've all become very familiar with this mode of meetings. I talk to different ones, especially those who have international connections, where it's virtual meeting after virtual meeting nonstop for 10, 12, 14 hours during the day. So it is the new norm. And I think to some degree, this is going to become the new norm, since so many of us find the commute from the bedroom to our in-home office to be such a delightful change from other commutes that there will be a big push in this direction. In some of the meetings that I've attended, the larger meetings, people have noted the fact that they should have been doing this all along. I mean, we, especially in our world of technology, we create this kind of capability, and we really should be using it. And of course, the good news is that we have it. We really do have it, and it works quite well and is working better as time goes on. So it's still seeing a number of people joining here, but we will proceed into the meeting. Beyond the welcome, I point out that this is our fall meeting. It is the first day of fall, so welcome to autumn, you all. I've had several people already this morning note the fact, where did the summer go? But this was the summer of COVID, and it is by all measures different from any other summer that any of us have ever experienced. But nonetheless, it's from a business standpoint, it's gone well. We do have a lot of work that has been done in these 9 months of 2020, and this meeting will give us an opportunity to check in on the progress that's been made. It's also a key meeting for us in that we will be previewing some of those all-important actionable recommendations, and that will lead into the sprint for the next couple of months to actually get those solidified and available for presentation in our early December meeting. So with that, I'm going to jump off and pass the baton to Ron Rapazzi, the Chief of the Office of Engineering and Technology, to provide his welcome and opening remarks. Ron, you're on.
Thank you, Dennis, and good morning, everyone. I trust you can hear me well. No technical difficulties. You were coming through loud and clear, Dennis.
Good.
Welcome, everyone, and good morning, and thank you for your participation in this virtual TAC event. That I echo Dennis's remarks about the efficiencies I think that we've learned to live with in setting things or conducting business such as we are today. It's been a busy summer, and it's going to be a busy couple of months leading up to the December TAC meeting and getting to those actionable recommendations. I've looked through all the slides, presentation materials.
Yeah, please mute your Yeah,
thank you.
Dancing, Ron. You got very well done.
So, thank you again for all the hard work that went into the past several months leading up to the presentations that we're going to review today. They're very thorough. I think we had an incredible litany of speakers that have come in to inform the various working groups. I know the FCC liaisons have been working very closely with the working group chairs as co-chairs, as well as the participants in the working groups. Weekly meetings did not go unnoticed. I know a lot of effort has gone into getting the draft recommendations to where they are today. So I'm not going to take any more time here other than to say thank you for getting us to where we are. And I look forward to the presentations today and the additional work that's going to go into getting to that list of actionable recommendations in December. Thank you.
Great. I think Manisha is on. Manisha Ghosh, would you like to, our
Sure,
Chief
Dennis.
Technology Officer for the FCC, would you like to share your comments?
Sure. Can you hear me fine?
Yes.
Thanks, Dennis. It's really my pleasure to have been a part of the TAC. I've tried to attend as many of the working group meetings as I can, simply because the subject matter has always been very interesting. The TAC has made very good progress over the last 6 months, and I think we are well on our way to obtaining actionable recommendations, some of which we'll hear today, and in the next 2 months, we'll get final recommendations for the FCC to consider. Each of the 4 working groups, and I've attended a lot of the meetings for each of them. They've had knowledgeable speakers exploring all the nuances of the topics they've been tasked with, just beyond just the technology. For example, the economic and legal issues of topics such as AI and Open RAN have been explored. So I think we are well on our way to getting a very holistic set of recommendations. And again, without much ado, let's look at the slides, listen to the recommendations, and look forward to the TAG continuing its great run for the rest of the year. Over to you, Dennis.
Thank you, Manisha. And actually, I'm going to pass it to Michael just to go through a few of the etiquette items. We've already addressed one. Please make sure that you're muting, especially those of you who have cell phones ringing. But
and before I do that, Dennis, also I'd like to just turn you over to Martin Doxgett, who is our Deputy DFO as well. Martin, anything you'd like to share? I know you've been attending a lot of the weekly meetings as well.
No, I think you all pretty well summarized it, but yeah, thanks for the recognition here, and I'm glad to be here. Thanks.
Great. So as far as the team meeting is concerned, I know some of you guys are more power users than I am. I'm kind of learning as we go. So obviously we talked about muting the microphone. And also feel free to turn off the camera if you feel like. Just because you turn it off does not mean that you're not paying attention to us. So we all recognize some of the things that kind of might be going on in your backgrounds. And also this time, I will try to run the presentations. Excuse me. I haven't put all the slides into a single deck. So I'll try to run it, and I'll try to make it as interactive as possible, switching back and forth from the presentation mode as well as a video mode, especially when you get into some discussions whatnot, so that you can actually see some of the familiar faces. Match that with the voices as well. And we may run into some technical difficulties as I'm learning, but we'll try to manage it as much as we can. So with that, maybe we can jump into the next item, which is the announcements and the roll call.
Well, I will just add a couple more things for Teams. For those of you who are not familiar, in the upper right-hand side, there's a little hand that is there. Please punch the hand if you have a question. This is different from our use of the chat, but just raise your hand and we can recognize you that way. There is a participants list that you can hit if you want to see who else is on. And there's also next to the hand, just to the left of the hand, is a little box with squiggles in it, and that's the chat. So you can put your, if you wish to capture a question that way, that's a great way to do it too, and we can tee it up that way, but feel free to also do it in the more normal way of humans, raise your hand as opposed to the tent card that we normally use, and proceed with that approach. So with that, I will move into the opening announcements, and we've kind of covered a few of those already, but first off, I would like to welcome Bill Check, who is with us from NCTA. I think Bill is on, but welcome, Bill. And he has been actually involved since June, but this is his first TAC meeting, I believe, and we're glad to have him here with us.
Thank you, Dennis.
Great, so you are there. Super. And want to make sure that we ensure that we do have a correct connection here. Actually, the names are listed, but we're going to go ahead so that we can hear your lovely voices. I'm going to have Michael do a roll call, and if you just indicate your presence, and we'll move through the cycle and then jump into the presentations that Manisha suggested we get to quickly.
Great, sounds good. I just go by the alphabetical last names. Brandon Abley from Nina. Brandon. Shahid Ahmed. Mark Bellises.
Mark Bailiff is here.
Good morning. And Naomi Bergman.
Yes, good morning. Hi, I'm here, Michael. Good to see you all.
Yep. And Bill Check. We heard you, Bill. Thank you
Yep.
for joining us.
Thank you.
And Lynn Cloudy from NAB.
Claudia's here.
Good morning. And Marty Cooper. Marty, I know you were there. I'm not sure if you have resolved the microphone issue.
I am present. Can you hear me?
Perfect. We can hear you loud and clear. Brian Daly.
Yeah, good morning. This is Brian.
Good morning. And Satish, are you with us today?
Yeah, good morning. Michael, can you hear me?
Sounds perfect. And Adam, you are here.
Good morning.
Jeff Foster from Intel.
Yes, good morning. I'm here.
Hey, Jeff, we can hear you loud and clear. Hey, Dick, I saw you earlier. I hope you're back.
I'm here.
Good morning.
Good
And
morning.
Lisa, you're here.
Mm-hmm.
Well,
Here?
Yep. And Russ, are you with us?
Yes, I'm here.
Great, Russ. And Dale, I saw you earlier as well. I hope your audio is working fine.
Yeah, I'm here. Thank you.
Great. And Steve Hayes, are you with us?
Yes, I am.
Great, thank you. And Mark Hess from Comcast. Mark, haven't seen you yet.
Yeah, I'm here.
Great. And Peter Kuhn from Boeing.
Here.
Hey, great, thank you, Peter. Hey, Kari, are you with us? Haven't seen you yet.
Good morning, Michael. I'm on.
Great, perfect. And Steve Lanning from Viasat. Steve? You might be on mute. Maybe he will join us a little later. Hey, Greg Lappin, I think I saw you, Greg.
Good morning, Michael. I'm here.
Good morning. And Kevin Letty, I saw you earlier as well. Good morning, Kevin.
I'm here. Good morning, Michael. How are you?
And Brian Mark Walter from CTA.
Yes, I'm here also.
Great. Milo, are you on? Did not see him yet. Lynn Merrill. Hey, Lynn, I saw you earlier.
Yes, I'm here. Good morning.
Joining us. And Paul Meisner from Amazon. Paul. And Jack Nizelski. Jack, are you with us? I have not seen him yet. And Michael Nawrocki from Addis. Michael?
Yes, good morning. Good morning.
Hey, good morning. Art Nichols from Windstream. Art? Madeline Nolan from ATSC. Madeline, are you with us?
Yes, good morning.
Hey, good morning. And Ted Rappaport from NYU Wireless. Ted, haven't seen you yet. Okay. And obviously we have our chairman, Dennis. Jesse Russell. Jesse, are you with us? Haven't seen him yet. Travis Russell. You might be on mute, Travis, if you're on. And Hans-Jürgen Schmidt, Facebook. No. Marvin Servu from CMU. I thought I saw you earlier, Mark. Maybe not. And Kevin Sparks from Nokia Bell Labs.
Yep, I'm here, Michael. Morning.
Morning. And Vince Spina from Juniper. And Paul Steinberg from Motorola Solutions.
I'm here. Good morning.
Hey, good morning, Paul. Good to see you. And Tom Swanberry from CTIA.
Yes, good morning, I'm here.
Good morning. And Dave Tannenhaus from VMware. And David Young from Verizon. David, I think I saw you earlier.
Sorry,
Good morning, Michael. Yes,
Yeah,
I'm
Good morning.
I think you had, this is David, just confirming I'm here. I think I'd been remotely muted.
Got it. Hey, David, thank you. And lastly, Charlie Zhang from Samsung.
Hey, Michael, good morning. Michael, good morning, I'm here.
Great. Good morning. Thanks for joining us. So that's, I think, again, have one of the highest attendance for this tech meeting. Thank you for joining, all of you.
Hey, Michael, this is Steve Lanning. I was on mute. I'm here.
Oh, great. Thank you, Steve.
And I think Shahid is also here.
Shahid? Great.
And this is Marvin Serbio, and I'm here.
Okay, great. Thank you, Marvin. Okay, made all the changes. And with that, I think we're ready to jump into the presentations. Dennis, unless there's something else that you'd like to...
Just, Tom, you had raised your hand. Did you have something that you wanted to mention, or?
Nope, I inadvertently clicked the wrong button when I was trying to put the meeting chat on. So.
Okay, no problem.
Apologies.
And Greg, did you have something? Your hand is raised. Greg Lappin.
No, I don't. I have to figure out how to unraise my hand.
Some involuntary hand raises. Have to be careful with that. You know, like an auction, you may win something you didn't expect. All right, with that, and I'll just echo what Michael said while he was running the roll call. I did do a count, and we're at a little over 40 members. So the virtual meetings do have a certain virtue to them, in that it makes it easier for people to attend even when they would have difficulty making their way to Washington. So there are advantages and disadvantages. Obviously, I think all of us miss the opportunity to be together and maybe break bread together the night before and those kinds of things. But from an efficiency standpoint, it really is very, very positive situation there. So we do have a question here on phone bridge with this meeting. I think there is a phone bridge. Is that not true, Michael?
I don't believe we have a phone bridge, separate phone bridge. I think we're just doing everything online.
Okay, online or Teams.
Correct.
Yeah, for those in transit, we probably should have had a phone line. Maybe we can arrange that in parallel. But let's jump in, and you have the agenda sent out to you, I believe, but the order, just to make sure that the presenters are aware and everyone else is also prepared. Artificial intelligence, obviously, since the screen is up, will go first, followed by the future of unlicensed operation, and then 5G RAN, and finally 5G and IoT working group. So that's the goal. We're looking to break for lunch at noon, and given that a lot of you do use that time for meetings, we'll try to observe the noon till 1 time. But if you are not in a meeting, we'll probably open things up so that people can also use that as a social time, which would be the case if we were in person. So we'll keep the Teams meeting open through that noon hour period, and people can interact as they will. All right, with that, take it away, Lisa and Adam.
Great, thank you. I guess I get to start off here.
So before we start, I had just a couple of comments. You know, the first one being, as Adam and I were preparing this presentation, we had such a wealth of information from all of our speakers, and we felt it was important that this presentation can stand alone because quite often that's how people consume it, especially after the fact. So there may be some verbose slides in here, but there's really valuable information that will end up getting incorporated likely into the white paper. And so this won't be a necessarily a fluid, salesy kind of presentation. We may be skipping through a few slides, but I just wanted you all to understand some of our decision making behind that. We could have chosen to put some of it in the appendix, but then it tends to get overlooked, and we felt it was important. So I just wanted to start with that. You know, that will be some of the pace. And Michael Ha, apologies in advance if we're skipping through a few things a little quickly. We just want to make sure we get through all our slides too. And the other comment I want to make is how much I've enjoyed working with our FCC liaisons this year. There's been such engagement and interaction, and I believe it's really helped contribute to us feeling much more confident in our recommendations and our draft recommendations starting to land toward the right thing that will be the most helpful. So I just want to do a special call out to our liaisons this year for that. So if we can go on, let's look at the agenda. Next slide. Am I moving them or? Oh, there we go. Back one. That's it. Thank you. So we'll go through fairly quickly the first three topics: the working group members, the charter and objectives. Those are largely reminders. I just want to show a short list of speaker presentations to highlight all of the knowledge that's been brought to us. For today's presentation, the meat of this will be in the findings. So this was a lot of what I was speaking about earlier. There's a lot of detail, a lot of findings that we've had, and this will inform us as we finalize our recommendation and the white paper. Then we'll close with the deliverables we expect and some early thoughts for next year. And I emphasize early. So let's skip through Michael will go through the members. Those are there to read the charter, the charter. So the same charter that we've always had is broken into 4 areas. So if we could forward to the next. Objective 1, we wanted to look at some of the spectrum challenges. We had several speakers on this. We have some findings from it. Let's go to objective 2. Data has ended up being really, this objective has turned out to be quite hefty as we're getting information, and we've had a lot of learnings in this area. And when Adam is up on the findings, you'll hear quite a bit of information about that, and also open things we want to highlight. So objective 3. Meaningful information and what we can extract. So we'll be covering that as well. And that was one of our objectives. And then I believe our final objective, which is objective 4, and legitimate use and risks. And we're calling that safe use of AI. So we're working in this area too. So if we could continue and page forward. So just summary of speaker presentations. So we started out with a variety of speakers on all types of topics. We paid special attention to ensure that it was most relevant to where we felt would be applicable to the FCC. So we asked folks from telecom, we asked folks from research communities. We've included Google, across the variety, and we also, as you see, we have institutions and academia analysts from different topics. The next slide. And we had our DARPA Spectrum. We heard from the top 2 winners from the DARPA Spectrum Challenge. Those were quite interesting. And we also, as Monisha mentioned earlier, we had 2 separate sessions on legal aspects of AI, which I believe is very important when looking at this holistically as a technology. And you'll see here security, Jeff Elstadt, security of AI systems. So we're starting to hear more about the safe use of AI. And then one more slide. And again, different. We heard from NIST, different academia, more large vendors like Nokia, who are very familiar with the telecommunications space. And then the final speaker slide. These are our upcoming speakers. One more slide. And we have these scheduled, and we're being very judicious. We have a lot of work we have to do. And what we're doing now is we are filling in gaps of where we need to understand things. So we want to learn more about the GIS systems for telecoms and OpenGIS. So we've got Kumar Navalar coming that will start to that will really weigh in as we talk about broadband mapping, internet and AI, and some futures there. Propagation data, that was another area called out by our liaisons. So, I think we've got some really good speakers coming up. And to get all of our deliverables done, I'm sure, well, we know we're going to have a lot of side meetings as well. So our work won't be limited just to the weekly meetings. We've got a subgroup going, and we also will have some one-off meetings of small groups of 3 to 4 as we dive down into some of the recommendations. So with that, let's go to the next slide, and I believe Adam is up. And Adam, I hope I've given you some good time here to go through this.
Definitely. Okay. What I'm going to do is walk through the findings. If you could advance this, please, Michael. Okay. What I'm going to do is actually cover 5 areas. I think 2 of them really deserve the most of the time on this. I'm going to begin with artificial intelligence, which includes machine learning and other methods. I think we covered quite a bit of this last year, actually. But if you look at artificial intelligence, it really involves a lot of computational techniques. There are major branches of AI, and there really is a plethora of methods and approaches within AI. We're not going to delineate all of them. I think you'll find in this presentation, we actually sort of devolved to looking fairly deeply at machine learning, and there's a good reason for that. I think if I were to start off with sort of the look at AI in general, starting with an important meeting in, I think it was at Dartmouth in the mid-50s, one of the prominent figures in the field sort of got back to his lab at MIT and said, well, I'm going to have artificial intelligence in 2 weeks. It's a joke I've probably repeated, but here we are 2 weeks later, still waiting for general AI. I think an important point to make is that a lot of AI over the years has actually sort of hit the marketplace. It's fairly deeply deployed in all kinds of products. It is, when you start looking at what analysts say, telecoms is looked as one of the lead fields that's exploiting AI at this point. Within the branches, as I mentioned before, is machine intelligence, and that's probably getting the most investment and attention at this point in time, and there may be a good reason for that. So let's go on to the next slide, please. So if you take a look at the various flavors of machine learning, I think the promise is that it'll allow us to deal with some of the complex problems that are important to network planning, design, control, operation of the network, management of resources such as spectrum, and technologies that are really building blocks of network architecture, sort of really going down to the device and component level, and an incredible amount of work on customer services, and customer interactions, where you see really sort of the emergence and wide use of things like chatbots. There is something that is really dramatic in the background. I think if I were to look at the last 20 years, an explosion, particularly of wireless services, serving around over 4 billion people around the planet. If you look at the penetration inside the US, it's over 100%, meaning that on average, an individual will have more than one wireless device. But in the background on this, and I took a look at the projections yesterday, by many counts, the number of connected devices is somewhere north of 30 billion at this point in time. Okay? And if you were to look at what is likely or possibly will happen in the next decade, maybe even 2 decades, is that the major growth is going to be in machine-to-machine traffic. And I think the consequence of that for all of us, for the industry, and I think for the FCC, is that the nature and the considerations we'll have to look at are somewhat different than just serving the consumer segment. In fact, a lot of the progress may actually happen outside of the consumer segment. So if you then take a look at the sheer scale that these connections represent, it's actually hard to imagine how one can get by without a much, much deeper level of automation for all aspects of what's happening in the network. And if I were to look at sort of our sister working groups, a lot of that has actually shown up in spectrum sharing. It's shown up in the 5G group, and it's dealing with sort of those increased scales, but also new capabilities such as network slicing. So when we look at this, AI is not just a tool, it really has the potential to be a game changer. Let's go on to the next view graph, please. Okay, I think in highlighting AI, it's actually important to point out that there are other techniques that we use, forms of analytics, simulation, modeling, statistical methods. They still employ computing. They still need data. But what is important to sort of understand philosophically is many of those methods sort of make the assumption and really try to, at the heart of it, understand the issues that we face at a cause and effect level, okay? And in doing that, they too depend on sort of the improvements in instrumentation and observation. And so while we may be considering AI, it's important to not abandon the usefulness of the more traditional techniques that are around. Now, if you take a look at what ML is within AI, it's really built on pattern recognition. And philosophically, what's different is that it isn't about understanding cause and effect. It's recognizing patterns. If I have a given input, what's the output going to be? How do I correlate the two? And what it might save you is not having to deal with all the ugly things of the physics involved, the chemistry involved, the mechanics involved, and therefore it really is very, very different in nature. If you go on to the next view graph, please. So the other aspect of machine learning, again, I'm focusing on a sub-branch of AI, is that while we have learned that it takes a tremendous amount of data to satisfactorily train a machine learning system, executing those learnings happens on a much, much faster time scale, often 4 to 6 orders of magnitudes faster. So what it allows you to do is to build fairly simple devices that can be embedded all over the place, that have and use the weights from the training. They use them in such a way that they can quickly recognize a pattern and do something useful with it, okay? And in fact, this is really sort of the allure of why AI may be very different in nature from other tools and extremely important. Okay, in actually making it work, one of the things that you have to do is collect data. It really has to cover the situations that you're interested in extremely well, sort of understand the important features in it, okay, and tuned to really sort of be able to improve how well it does, either from additional data or new data that's used for training because we recognize that something was left out. The next thing is, public perception that, somehow general AI is what we have. We're still very far from it, okay? And so the systems that we are dealing with quite often have a hard time recognizing the things that we do well as human beings, application of common sense, understanding of context, things of that sort. Nevertheless, okay, in many, many aspects, what you get out of AI, including machine learning, but some of the other aspects which we call narrow AI, very significantly, they can very significantly exceed what we can do in terms of human performance, okay? And I think a few of our speakers emphasize this, that you get the best solutions, but really sort of taking a systematic look at what your tools are, not just ML, but a mixture of traditional methods. And in fact, when we looked at something very specific like the Spectrum Challenge, all of the winners didn't use sort of brute force ML. They ended up relying on both traditional techniques and other aspects of AI. Let's go on to the next view graph, please. The next thing is, if you take a look at machine learning, it is highly likely that it'll be extensively used within the network to perform important and critical functions. So as I mentioned before, AI doesn't always perform well. Sometimes it makes unexpected errors. I think the style today, very many useful things where we still have a human being in the loop. I think if we go to sort of full automation, it really is important to figure out how do we deal with the things that are surprises, okay, and at the same time sort of really examine what is acceptable and what is not. And I fold that in under sort of the topic of the safe use of AI. Within the cycle of machine learning model preparation, testing, deployment, there are also new vulnerabilities. So security, privacy, and trust regimes are very important. There is actually legislation in this regard that's already out there. And it poses sort of two important questions. Again, how can AI, ML techniques be used safely and reliably within the networks and as part of service offerings? Okay. And the second area really is what are appropriate metrics for acceptability. Let's go on to the next view graph, please. So the next thing, again, repeated by quite a few of our presenters is, if you want to do something with AI in terms of how it's used and employed, if you want to make decisions about how somebody will employ AI on your behalf, it really takes, I would say, a lot of resources, experienced staff, knowledge of AI technologies, and really sort of familiarity with the emerging AI ecosystem. And so I think when we look at recommendations eventually to the FCC, I think it's important to sort of identify a promising set of areas, which we present later in the briefing, but really start thinking about, what are the organizational impacts of getting deep into AI and starting adopting some of the methods and techniques. So let's go on to the next one, please. So I would say, in summary from this, there were really three things that came out related to AI. The first is the importance and criticality of data and its availability across the AI ecosystem. I think I mentioned that to use tools like machine learning within AI, all of the knowledge-based systems, if you don't have access to data, if you don't have it at a very complete level, it's hard to make progress. So we see the FCC as playing a positive role in this area, okay? And in the end, it really sort of impacts two things, industrial competitiveness and the competitiveness of the telecommunication industry. The second thing that stands out is really the transition of the nation's networks to be dominated by machine-to-machine traffic, where access to computing and data storage is broadly available. So this is not only the problem of how do you optimize the telecommunication assets, but really how do you create access to the other assets that are necessary and in a systematic way lead to some degree of optimal use of all of those. And then the last one that comes through is that AI poses some very new challenges and new phenomena as far as, I would say, security and privacy go, assurance, the safe use of AI, and again, the impact that has on services and applications. So those are the three things that really stood out. If you go on to the next view graph, please. You find out whether something you're working on is serious or not by how it ends up in the funny pages. So there are a lot of perceptions by the public of what AI does and doesn't do. It's also worthwhile paying attention to. I particularly like the cartoon in the middle where you have a chat bot and somebody says, gee, can't we use artificial intelligence to manage our sales funnel? And like AI does once in a while, totally out of context, they tell you where you can buy your funnel cakes. So let's go on to the next one, please. Okay, I think we pointed out the importance of data. So let's go on to the next view graph. It's a label. If somebody tells me I need data, this was actually built into our charter, it's hard to understand what they actually mean by that. Because there is a lot of things that are conveyed by that label. There's a lot of diversity in it. There are a lot of stakeholders involved in data, lots of stuff with third parties that you have to deal with. So I'll be, I would say, diving deeper into that. The next thing is that if you have a particular application or a particular problem to which AI is to be applied, it's not just taking any data, it's bringing some intuition to the table to actually understand what data is important, what the features have to be in the data, Okay, and that itself is a learning exercise. So if you look at it, the way things proceed is you start building models around the intuition that you have. As you proceed, you start figuring out that, hey, I really have to refine this, change it in some ways. So there is a considerable amount of thought that has to go into, first of all, what constitutes relevant data? And the second thing is what constitutes data that really covers the set of conditions that I'm likely to be facing that I need to have there. And so access to data, whenever you're going to deploy AI solutions, things of that sort, and the rules around it are really critical because for businesses to invest in this, having some certainty about the, what the rules of the road are, what they can put into their plans and assumptions to build a business is absolutely critical, okay? So I'm gonna skip the next one. Let's go on, please. Okay, so here is another important aspect. Having listened to a lot of folks, I think done a certain amount of research within the group, one of the points to make is that whenever an AI-like solution is put into place, 50 to 80% of the budget of a project is actually likely to go onto things that deal with data. There is a little chart from Mark Cusack from Teradata looking at typical projects that he has faced. And what you find is the ML code, the hardware I'm going to use, it's very important. You can't do it without it, but it tends to represent a very small part of the budget and the activities that you will be involved in. So I've gone through sort of a list of steps of what's important, identifying the right data, that feature selection, input and collection of it, moving it to the places where I need to be working on it, cleaning and annotating it, storage and management, the analysis, sharing and distribution, and updates as I go through and collect it. Okay, and so that's one thing that's necessary. The other thing for emphasis, there's a good set of white papers and reports that McKinsey put together. There was a fairly good HBR article written by Michael Porter and one of his associates, really looking at the kind of resources, domain expertise, and the amount of time it takes to actually get value out of AI-centered projects. So with that, let's go on to the next view graph. Okay, so as I had mentioned before, that labeled data means lots of things. This is by no means a comprehensive list, but the data comes in all kinds of types, can be deeply technical things, specs. It can deal with operational issues, performance issues, customers, various forms of documentation, results of survey, and even legal data can very much be part of it. Typical set of characteristics, the 7 V's, sources, where does this stuff come from? And again, lots and lots of options there. Who actually owns the data? And what are the regimes, legal regimes that rule it? Okay, all of these are considerations that have to be taken into account. Let's go on to the next one, please. The next thing is that the oversight of the data carries responsibility with it. Some of them legal, some of them, I would say, prudence, essentially. But it's data security, cyber security, privacy, trust at many different levels, essentially, and a long list of requirements that deals with reliability assurance, access, and things of that sort. And so in this area, there's an active area of research to actually try and figure out, how can you actually deal with data, produce results, and at the same time, I would say sort of stay within the guardrails of what's required. Okay. And then very important, I think we heard this over and over again, some of the folks from the research community, but I would also say some of the operators and vendors, access to data sets is super important, essentially, okay? And if you don't have it, it's hard to make progress. So there is a lot here where I would say sort of the future of the industry and its competitiveness, there's a long trail of activities that have to be supported. Some of them have near-term impacts, but in the long term, this is something important to watch. So let's go on to the next view graph, please. Okay, the next thing to get across is that data has a life cycle to it. While you may think that you're gathering it for a particular project or a particular purpose, it's surprising how often data has multiple uses. And I would say almost all the practitioners who are good at this say, hey, once you put your data together, its value actually increases over time. It inherently serves you better if you are able to share it across your organization and across the ecosystem. In this case, it would mean other federal agencies, state governments, the operators themselves, suppliers, consumers, industrial enterprises, down to small businesses, and the research community, okay? And so having those kind of mechanisms put in place also becomes important. And examples are things like broadband usage and availability. It's where businesses do their planning. It's where the sociologists worry about what our economy looks like. Same thing with spectrum usage. If I take a look at location of interconnect points and ability for somebody to hook into the network, tremendous difference. Patterns of outage reporting, where are they happening? Are we building out the right stuff? All of those things, that data tends to be fundamental and reusable over and over again. So curation of data is an important aspect, in fact, for AI and ML applications. And, there is, I would say, sort of a missing chink in the ecosystem. And that is traditionally, it's an activity that the research community rarely pays for. I would say enterprises do it to some extent, but again, limited. And so it's something worthwhile paying attention to. Let's go on to the next one. Okay, so this is again, just like with AI itself, there's an aspect to data that requires guardrails, protection of personal and private information, visibility into the validation of the data if it's used for significant decisions, and then analysis and testing of AI used for control and critical functions, essentially. I think the other part of this is really sort of standards and best practices, and that is consistent approaches to metadata, identifying the meaning, time, source, labeling of it so it can be used in many different contexts. Let's go on to the next one, please. I think, again, from the presentations, we found out that there are quite a few other organizations working on data and data life cycles. NIST has built a framework in this area. NWDAF within the 5G organizations is an important aspect of things. So I would say understanding the issues and who's doing what in the data place is very important. We heard from Mazen Gilbert from AT&T that he's working with the Linux Foundation on collaboration, in fact, in figuring out how can you share certain aspects of data and actually the underlying models that will be using it. Again, that ability to share data, have a set of rules and legal foundations for doing it becomes fairly important. Next one, please. Okay, so I think in terms of a summary, I would say the feeling has sort of emerged from all of these things that there really does need to be a set of clear policies and approaches to the sharing and dissemination of data, the kind of business models that go along with it, because the FCCA relies on data from other parties for what it does. It collects some critical data on its own that others rely on. And I would say it's sort of in how the FCC promotes the adoption of AI, ML technologies where it's applicable. I think, this is an area that needs.
A quick sec or no?
Hello?
Okay. Oh, that's plenty of time. I'm just sitting here. I'm quadratasking right now. It's fascinating. Wanted to check. Naveed is going to put Dave on the.
Could somebody go on mute, please?
Which I'm fine with. It's good exposure.
Or Mike, Michael, can you put them on mute?
Okay, it's gone.
Thank you. Okay, so let me come to the summary on this. The second is, the second item in the summary was the acquisition and curation of meaningful data sets, very important. And then developing a data regime that serves the FCC and the nation in a reasonable way. And that, I would say, includes staffing, expertise, time, and money, essentially. Let's go on to the next topic then. The next view graph. Okay, and again, if you look at the whole data sphere, what you will find is everybody needs to get a razor. I think those are statistical methods, but a lot of humor around this also. Okay, let's go on to the next view graph. Okay, so I think the three remaining topics, I'm not going to spend a lot of time on them, was federal investments in AI, broadband mapping, and projects of interest to the FCC. So let's hit the first one. Without going into detail, I would say we heard a lot of, I would say, intriguing ideas. I would say areas in which exploring AI really promising some very important outcomes for the FCC. We found a lot of the work was still in its early stages. And if I were to do sort of a picture of a stack, where at the bottom you have sort of the physical layer or the most technical things, to the top of the stack where you're dealing with customers, there is a lot more that's going on in that customer space than in the physical space that's already in deployment. And the flip side is there were intriguing enough results from things like the spectrum competition, et cetera, that one could sort of say, hey, this may be important. Let's figure out how it could be reformulated so it actually serves something in the sphere where the FCC considers it, I'd say, both timely and relevant, and actually deals with the requirements of what commercially run national networks are all about, the kind of scale that you have to deal with, okay? And all of that actually requires availability of data to be able to head off in that direction, okay? Data curation, I think we mentioned that before. There has to be something in the ecosystem that allows us much better to deal with data and look after it over its lifetime. And I think those mechanisms are missing. Let's go on to the next one, please. Okay, I'd say the last one is there's a lot more stuff on the research space, but there were also a few agencies, such as NIST, for example, that have already created fairly good frameworks for data, the whole discipline around it. And that was done with fairly broad industry participation. Maybe not as much with telecom as there should be. Rather than build stuff from scratch, it's worthwhile taking a hard look at what's already out there. Let's go on to the next one, please. Okay, broadband mapping, if I could sum it up the following way, there is a lot of capability out there. If you look at something like a broadband map, it's not just a map, it's going to be used for a purpose, I assume. That purpose is to help people plan things, eventually make decisions as to how the unserved or underserved will be taken care of, what's the best way about going and doing it. So in some sense, AI can play a tremendous role there. In fact, from a few speakers, I would say, the impression we got is that network planning, how you do build outs, how you put equipment in, do siting, things of that sort, AI really promises to improve efficiency across the, really across the industry. It's an area in which there can be tremendous gains. Okay, and so our feeling is that there's enough capability out there that the right thing to do is put out an RFI, identify who the players are from that, get some understanding of the resources of what it would mean to put a map like this together, all the integration, the many areas from which data has to come, and then once that's in hand, really make a decision as to what the FCC wants to do in-house versus what it should actually procure through some form of an RFP. Okay, let's go on to the next one. So I'm going to skip that. Okay, the last area is sort of areas of interest to the FCC. This is a limited set of examples. I think we've had a lot of discussion with our liaisons on this, but it's improvements of propagation models, because in the end, how those work determines the regimes you put on interference and things of that sort, and its avoidance. It determines the efficiency with which spectrum is used. And it also affects the way spectrum is shared. So lots of implications there, and tongue-in-cheek, sort of getting away from Longley Rice and having something much finer could have profound impacts on what we do. Next one is identification of interference sources, whether it's having smart sniffing devices that are deployed on fleets of trucks of third parties, satellite readings, lots and lots of different possibilities there, but again, very ripe for exploitation of AI. Trading models for data sharing, spectrum sharing, sort of the economics of things, again, fairly important. Analysis of outage data, If you go into the next view graph, the FCC receives a lot of comments to its NPRMs, things of that sort, in-house analysis of those using AI for that. Very important one, the FCC is a keeper of lots of databases and websites. Again, coming up to speed and doing this at a level of really providing the kind of services, search capability, and the tools to exploit AI by using that data in the databases is fairly important. Network security and privacy, lots of uses of AI in this space. I already talked about things like spectrum sharing, robocall and other similar annoyances, emergency response, and then to get ahead of the curve, preventing adversarial uses of AI. So this is sort of the dark side of AI at this point, and many, many others. So this is a list we hope to fill out. I don't think I captured everything that we had discussed in our deliberations during the year, but there's a lot more there. Okay, if you can go on to the next view graph, please. So I think at this point, what I'd like to do is turn over the mic to Lisa and have her talk about the draft recommendations. Lisa, you're on mute.
I wasted those words. So much of the groundwork's already been laid by Adam in what's going into our draft recommendations. I am conscious of time, and I don't want to short our next group for their amount of time. But let's go through these. So the first recommendation is that the FCC should have a strategic plan for AI and data that explicitly deals with potential impacts across all bureaus and offices. This is very important, and it's going to be very important to be specific about what should be considered in the plan. During our 2 years when we've been focused on AI, it's quite easy to delve into areas that may not be as relevant to the FCC as others. So in the plan, it must define boundaries where it's helpful as it relates to interests of the FCC and exclude where it is not helpful. And caution has to be exercised to avoid hype and really focus on deliverables. So in case all these bullets aren't relaying this, and this is what we hope to flesh out is meaningful input to the FCC on where we should and should not focus. Caretaking of AI requires considerable resources, so we have to be judicious. The plan should include a vision for AI that's still left to be defined. This is a really important area. As we've gone through this, and you saw that in what Adam just presented, all of the different areas of relevance, and it covers things from highly technical spectrum sharing and calculations all the way up to very efficiently dealing with customer input. And so AI is a challenge in that it applies to almost everything. It's helpful to everything, but it's a challenge to be sure that we bound it. So let's go to the next slide. AI as a tool should be included in the plan. We called this out because this was a big debate in our working group, and we came to the conclusion that many people do consider AI as just a tool, but our contention is it is a tool, and it's a valuable tool that should be fostered and consciously looked at and watched over rather than assume it's a tool and it will take care of itself. And the reason for this recommendation, having the solid plan helps the FCC to understand what to do internally and when to leverage a third party. This is important, and you've heard us talk about this theme. There are a lot of pockets of work going on across agencies and in the commercial world as well. So I believe it's judicious, or we believe it's judicious, to understand when to do things internal, when to leverage external, and how that balance should align. It should define why is AI important to the network so that this is clear. AI, again, if you think of general AI, it's hard to understand all of the areas that it applies. In this case, it should define here is where AI in particular applies to the network. And it should it should also refer to areas where AI, ML are in use today with positive benefits and promise as a roadmap or an example of how AI can evolve even further in the future and become even more and more useful and integral into everything. And the plan should address what tools and infrastructure the FCC may share or share with or develop to address common problems across multiple agencies. Again, avoid rework, avoid overlap, and be very conscious and deliberate in that aspect. Let's move on to the next slide. Federal investments. As we talked about earlier in the findings, there are many areas where there are federal investments. There are many opportunities to leverage these investments and research in AI. What we did find is a lot of these investments may exist in somewhat isolation because there isn't common data. So you're hearing some themes that we're talking about that will show up in our final recommendations. A common finding we had was that fundamental challenges exist around access to data and in sharing data, and we believe the FCC could be a very good mediator for the entities. The FCC also has applicable use cases internally that can benefit from AI. We looked at that in the earlier slides, so I won't belabor it, but we want to incorporate that into this recommendation. And again, focus on areas where to partner with other entities so that work isn't recreated and overlapping. And we also want to specifically note that engaging the research community is important, and it will continue to be important to move this area forward. Next slide. Data. This is probably our biggest topic. So we will leverage a lot of the work in the findings, and we're going to plan for some recommendations around the data structure and how does the FCC bring these to bear. And curation is the key. Does the FCC own it? Do they develop it all on their own? No, but there needs to be a place, an entity that can curate the data structure, developing clear policy, considering this in context of other organizations, don't duplicate work, partnering with other entities, and leverage good frameworks that are already there. Take care to reuse and leverage and align with these. And as Adam mentioned, the FCC itself is a keeper of many databases that are useful for the research community. If we had more extensive curation, it could be even more useful, and we believe that the projects and investments might not be as isolated as they are today. Next slide. Safe use of AI. This is one that we believe will show up in our recommendations to go further next year, but here are our observations is that AI will become more and more entangled with network systems, and this does bring danger. And the FCC needs to look carefully and think through how AI could be used and ensure we don't introduce compromise. This could be in the terms of ethical issues, resistance to attacks, integrity of data. That's just a few examples of many. And a key point I would like to make is the more powerful AI is, the more adverse the consequences it can enable. And we will plan to raise a very large caution flag in this area so that we as a nation get ahead of issues that we might see here. Next slide. Broadband map RFI. Adam's already talked about this extensively. I won't belabor the point, but we do believe that issuing an RFI will help in many ways. So it's a real project with real deliverables that are quite valuable, and it will facilitate learning. It will provide, this is a very important point, provide a vehicle to define specific resources to be allocated. And that includes not only funding, but that includes expertise. And it will also illuminate where can third parties help, where should the FCC do things in conjunction with third parties, and where should they take the lead. And it will create an important asset and the ability to learn and allocate resources. So next slide. And our final draft recommendation will be focused action in areas of interest to the FCC. So think about the table Adam showed toward the end of findings. We want to be very specific on some task forces, workshops, or forums in relevant areas, conducting pilots, and again, we'll provide that meaningful list in these areas. And let's go on to the next slide. So our deliverables will be these recommendations in final form with much more detail, integrating the findings in so that it illuminates the recommendations. A white paper that will not be a white paper about recommendations, but will be a white paper about the research and outcomes that we've had this year and considerations. And a relatively short one. We're targeting 18 to 20 pages so that it's concise. We already have an appendix of current AI research, thanks to the intern that worked with us this year. So that will be a deliverable. And then thoughts for next year that I've already hinted at. A working group potentially focused on the broad topic of data, and a potential working group focused on the safe use of AI. And with that, we come to a conclusion.
Get my own self off mute. Really an extraordinary presentation covering a tremendous amount of ground, and the group has really been very diligent this year, so really appreciate all the good work, both the leadership that you've provided, Lisa and Adam, but also the whole group and the contributions and those of the significant number of subject matter experts that you highlighted with the presentation. Our time has dissipated, but I certainly want to give at least an opportunity for a few questions. So if you have questions, please raise your hand. I don't see any at this point, but please do provide your questions. And I'm not seeing any. So let me ask one. Of the recommendations that you have, certainly the strategy recommendation for FCC is a considerable one. How do you see that being accomplished? The FCC itself may or may not have either the resources or the skills to be able to accomplish that. So do you have a thought on how that, I know it's not a formal recommendation yet, but it does beg the question how that might be.
You know, let me do the following thing. So I think the off-the-cuff answer would be to form a task force like the FCC formed for the National Broadband Plan. Okay, take it seriously, allocate resources to that, and supplement it, with resources from the outside. Okay, I think the value in sort of arriving at this recommendation is in the least to put down the top thought, I would say the top considerations for what should be in the plan. Okay, not immutable, but to do that. Okay, but there really has to be a task force. I would say it should include resources and expertise from the outside where it's available. Okay, and that was done for the broadband plan.
Yeah, no, I think that was an excellent answer, and it really, I think, was very helpful for those of us who were around when the National Broadband Plan was put together. That fills in a lot of blanks, and it also illustrates the magnitude of the activity that is needed, and a good suggestion on how it might be accomplished.
Look, I mean,
that was a very successful endeavor. It pointed the direction for a lot of activities that proceeded after it, and doing that sort of thing for AI would seem highly appropriate to me. So good answer.
It's all there's a great quote from Churchill who said, "Planning is useless, okay, but the act of planning is invaluable."
Yep. Familiar with the quote? Yep. No, excellent. Okay, very good. Well, I'm still seeing no other raised hands, which to me is actually extremely surprising. But given that
we thought this would be a lot more controversial somehow.
Well, you also covered a tremendous amount of ground. So even though a lot of the members were a part of the activity that created the deck that you've just gone through, it is a lot to digest. Well, particularly, I suppose, if you were not part of the group, which I did tend to attend a lot of your meetings. All right, well, let's move on then to our next speaker. And if you could pop it up, Michael. We'll move into our future of unlicensed operations, and thank you. So we're all done. That was. I think you're going the wrong way, Michael.
No, he's
oh yeah, no, I see. Yeah. Okay, there you go. So Kevin and Brian, if you would take it away now that you're teed up, and away you go.
All right, thank you. Can you hear me well?
Yes, quite
Great.
well.
All right, this is Kevin Letty. Brian and I will split our time with remaining. I'm going to cover the first couple of topics, the first couple of questions we were asked to address. And then the meat of our recommendation today is around 60 gigahertz and a recommendation that the FCC start a rulemaking to examine the coexistence between personal radar and communication services.
You are breaking up just a little bit, Kevin.
At 60 gigahertz, is that any better?
We'll still have to say a little more.
I'm sorry, I may have to switch microphones.
Yeah, you're just chopping a little bit.
Yeah.
The volume is okay, it's the chop. So it's coming across a little choppy.
Is that any better?
Much better.
All right, thank you. All right, next slide, please. So here are our working group members. Thank you to all of them. Particular thanks to those who helped us recruit the terrific speakers that we had so far this year. That's greatly appreciated. Next. So here's our agenda for the day. We'll review our charter quickly, and then talk about the subject matter experts that we heard from over the last quarter. We'll walk through our key findings and updates, and then look forward to what we're doing for the fourth quarter. Next.
And now if you would just speak up just a little bit louder.
Okay, sorry about that. I may have to switch microphones. So here's our charter again, broken into 4 questions. The first is, how do unlicensed operations, unlicensed spectrum, complement or compete with licensed services? The second is, how do unlicensed operations improve the user experience and potentially become more competitive? Third is somewhat of an overlap with the second, talking about new services and novel applications that are made available at unlicensed, and looking at the new standards that are emerging around unlicensed at Wi-Fi 6 and 7. And then are there sharing technologies available or emerging that will improve the use of unlicensed? And we ended up spending a lot of our time on sharing technologies, and we'll talk about that. And then the fourth question was very specifically around personal radar, and that's the part that Brian will cover in the second half of our presentation. Next. So the subject matter experts we heard from this quarter were mainly around 3 topics. The emerging standards that are being set for unlicensed operations, coexistence and spectrum sharing, and then 60 gigahertz use cases and coexistence. Next. So very briefly, here are the speakers that we heard from. I think as everybody has discovered this year, the work from home phenomenon has been terrific for the TAC. It's made a lot of subject matter experts available to us. People who would probably be traveling throughout the world this year are are at home and seem to have time to share their opinions. And so we've heard from a lot of highly qualified subject matter experts over the last 7 months. First, we heard some presentations around the emerging standards. Wi-Fi 7 from Intel and Ericsson gave us a good presentation on emerging 3GPP standards. Next. We also had several discussions, I think 4 discussions around coexistence between IEEE and 3GPP and the coexistence issues at 5 gigahertz and how those issues are being resolved at 6 gigahertz. And I'll come back to that. Next. Third area was around spectrum sharing. And here we heard from Google, who's one of the SaaS providers for CBRS. We had an encore presentation from Federated, which talked again about the operational complexity and issues emerging around SaaS operations. And then Cambium Networks, which has an interesting business model, sort of packaging up and dealing with the SaaS providers for the wireless ISPs, for the fixed wireless operators. And we'll come back to their recommendations. Next. And then finally, we had a couple of presentations on 60 gigahertz. Google talked about their Pixel 4 phones and the use cases for personal radar. And then we heard a good overview on the issues around 60 gigahertz in a combined presentation from Facebook, Qualcomm, and Intel. Next. So let me start with the first of our 4 questions. And I think with this presentation, we can put this question to bed. How does unlicensed spectrum or operations complement or compete with licensed? Next. And I think the answer is that unlicensed clearly both complements and competes with licensed operations. The complements are well known to all of us. The MNOs use a combination of licensed and unlicensed spectrum in their networks and leverage unlicensed for in-home connectivity. Depending on whose research you believe, at least 50% of the MNOs mobile traffic offloads to unlicensed spectrum through wireline ISPs like cable operators and DSL providers. Some estimates are as high as 85% of MNO traffic is offloaded. So the MNOs leverage unlicensed very well. WISPs also leverage unlicensed in a very opportunistic way. They purchase some licensed spectrum, but as much as possible, complement that licensed spectrum with unlicensed systems for their network. And then the broadband providers use a lot of unlicensed spectrum. They're not using licensed for their wireline systems, but they're leveraging unlicensed for their broadband services. Next. And then similarly, unlicensed is creating more competition all the time for licensed operations. So we've heard from several wireless ISPs, fixed wireless experts, and they're clearly, their access to unlicensed spectrum is allowing them to be more and more competitive with wireline ISPs. Wi-Fi hotspots similarly are used, unlicensed hotspots reduce the dependency of new emerging mobile networks, for example, from the cable operators who are MVNOs or all MVNOs. And by having more access to a wireless spectrum, the MVNO economics continue to improve. And so those MVNOs become better and better competitors to the incumbents. Similarly, 5G NRU is going to enable 100% RAN operations in unlicensed spectrum, which should create even more competition. Next. So I think we've talked about the value of unlicensed, and I continue to think that you could make a case that Wi-Fi unlicensed at 2.4 and 5 is the most valuable spectrum in the world. The Wi-Fi Alliance estimates that by 2023, the value of unlicensed spectrum in the world will be about $3.5 trillion. $1 trillion of that is in the United States. So the FCC clearly recognizes this and has made more and more unlicensed spectrum available. And that's going to be very valuable to industry and the economy as a whole. One of the things we're thinking about examining more in the fourth quarter is the way that unlicensed is used internationally. We've been focused mostly on the United States so far, but we need to learn more about the value of unlicensed around the world, and also about how sharing technologies are being used around the world, and then the progress being made by the wireless ISP community. Next. So questions 2 and 3, we sort of combined here, talking about the use cases that are emerging from unlicensed, the new protocols and standards that are emerging, and kind of where unlicensed goes from here from a standards perspective. Next. So we look first at the current wireless standards that are just coming out, the extensions to previous standards and the capabilities that they will provide, and then we'll get into the standards that are emerging a few years from now. Next. So the one that's being released now is Wi-Fi 6. Wi-Fi 6 expands Wi-Fi capacity by 4x through a set of new technologies. OFDMA, which improves access point efficiency, allowing our BSS coloring allows the access points to talk to each other better and optimize the available frequency. OFDMA also will lower latency. The security of Wi-Fi is improved through WPA3, through better encryption. We get faster performance through Wi-Fi 6 by increasing the modulation to 1024 QAM. And all of this is expected to be approved here in the fourth quarter. So Wi-Fi 6 will be a great leap forward, and then 6E is yet another step when the 6 gigahertz spectrum is available. And devices are built to accommodate 6 gigahertz. Next. Similarly, 5G NRU, I'm not sure what's happening to our slides here, enables some new use cases, allowing unlicensed spectrum to complement licensed operations. Those deploying 5G systems can use 5G NRU to aggregate carriers between licensed and unlicensed spectrum. Those carriers who are still using LTE can use NRU for dual connectivity. And then there's the possibility of standalone operations that would just use NRU, possibly in private networks like factories or other closed environments, neutral hosts, places that could be isolated to just use unlicensed spectrum. Next. And then the other emerging standard coming out in the fourth quarter is .11ay, which will govern 60 gigahertz. This builds on top of .11ad standard and will allow speeds at 60 gigahertz of up to 200 gigabits per second. Very impressive speeds and latency levels that should support new use cases like wireless AR and VR and greater sensing technologies, which we heard about from Google from their Pixel phones. Next. So what's on the roadmap from here are a couple of additional standards. Next. We heard about Wi-Fi 7, which will have even a 4x increase in throughput from Wi-Fi 6. Extremely impressive speeds and latency levels. 5G NRU has another chapter in release 17 that will allow NRU to be used in spectrum up to 71 gigahertz. And then there's a wireless LAN sensing and radar study group at IEEE that will deal with the coexistence issues at 60 gigahertz. So lots of additional standards and use cases in the pipeline that will maximize the use of the unlicensed spectrum that's available. Next. So as we looked at these emerging standards, a number of speakers, I think 4 of our presenters, addressed this issue of coexistence between Wi-Fi and LTE LAA. And we talked about this in our last report. It was first discussed by Boingo, the neutral host provider, that was saying that Wi-Fi doesn't play nice, or as nice as it should, perhaps, with LAA. And we got similar presentations from Ericsson and Cable Labs, and I think it was Google that also chimed in on this. And then, of course, Monisha gave us a great presentation based on her research at the University of Chicago, which identified the issue very specifically. And in a nutshell, what's happened is historically, IEEE has operated with energy detection level at -72 dBm, or at -62, excuse me, but a preamble at -82. And by having the preamble at -82, it starts to coordinate, Wi-Fi users start to coordinate usage and channels before the 3GPP devices coordinate at -72. And so I think we talked about this a little bit before, but ETSI for 6 gigahertz has harmonized the energy detection threshold at -72. Some speakers that we heard from suggested that the FCC look at this and possibly move to a similar standardized level. But the more we talked about it, the more we think that the standards bodies will work this issue out, and the issue should be left to the standards bodies rather than FCC action. Next. So next topic is spectrum sharing, and I think this is a very fruitful topic. We had a call among all of the co-chairs of the working groups a couple of weeks ago to talk about spectrum sharing, and there was consensus that this should be a topic for next year's TAC, that there's a lot of interesting issues around spectrum sharing, particularly the emergence of SAS, and that it's probably enough of a topic to justify our working group on its own. Next. So the summary here on sharing is that multiple industry experts came in and discussed sharing overall, and the sentiment was very positive. But the speakers also identified a lot of challenges around SAS. That first of all, it's fairly complex, and that it takes a long time for the FCC to certify SAS processes. Those processes the rules are somewhat complex. In fact, Cambium's business model is designed to deal with that complexity for the wireless ISPs, the fixed wireless operators. That there's potential to simplify the way SAS is certified. There are also some coexistence issues between the SAS operators, which provide difficulties for those who are starting to use SAS. There's a couple of speakers, Google and Microsoft, talked about the propagation modeling, and that I'll come back to it in a minute, but that there is opportunity for improving interference issues. I think we'll hear about that from other presenters today too. And then finally, I think all of the presenters who discussed SAS said there's an opportunity to create better metrics and key performance indicators around SAS so that we all understand whether it's operating as it's intended to operate. So more work is needed to understand the topic, the opportunities and challenges. Part of our fourth quarter report will be to summarize all the spectrum sharing findings as best we can. We won't get into recommendations on sharing, but we would at least like to catalog all of the sharing technologies that are available and get them better defined. And then, as I said, we should probably have a working group on this for 2021. Next. So on the propagation modeling point, I think Adam referred to the Longley-Rice propagation model that's still in use today. Google was particularly eloquent about this and had this great slide that shows how the Longley-Rice model sees Manhattan, which is without any buildings for interference. But in fact, if you deal with all the attenuation issues that those buildings create, you would come up with a very different propagation model for Manhattan. So I think there's the point that Google is making is that if you had an accurate propagation model for Manhattan, you would see that there's far less interference risk between the communications services, and that the unlicensed uses could be operated at higher powers without creating interference problems for the incumbents. That's something that we should be looking at. Next. So question 4 is what sharing technologies enable use within personal radar or additional bands? Next. So let me at this point turn this over to Brian, who's done most of the work on the 60 gigahertz issue.
All right, thank you, Kevin. Can you all hear me?
Yes.
All right. So this was an area that we held for this past quarter and got some great presentations on. Kevin already in the lead-in summary of our presentations alluded to a few of them. Let me frame this up a little bit as the emergency vehicle goes by. So 60 gigahertz, of course, this band's been open for unlicensed use for some time, but I think part of what we heard from presenters was that commercially it's growing for really a couple of reasons. There's a wide chunk of spectrum that's available there. So with a wide bandwidth, you can do really high throughput applications, or if you want to trade throughput and latency, you can pursue low latency or some combination of those. In the radar world, we'll get into this a little bit, but bandwidth means spatial resolution. So to do some of the radar or sensing type applications, you really have to be at 60 gigahertz to have a commercially viable system. These are obviously really short wavelength in this band, so you can do things that are becoming now much easier to do at volume We're just a lot better at doing these small antenna arrays or doing very short, kind of low power applications. And two groups are looking at it. I think we hear the most about communication systems, multi-gigabit kind of stuff that we just heard that standards groups are looking at, particular with 802.11, AD and AY, and 5G. NRU is also exploring this area. And the other application that we're going to talk about, and the whole premise of this section, is the two of these fundamentally different uses of the spectrum. The second being radar and sensing, are trying to live in the same band. That radar may go all the way from kind of room scale sensing of even a larger room down to pretty fine gesture control type sensing. There's really kind of two fundamental technologies. One is frequency modulated continuous wave, radar type, more traditional, and then what's called wireless LAN sensing. Next slide. Okay, looking a little bit more closely at the use cases themselves, and these were from presentations that we've had. Top half of the slide are the communication side. Actually, there are dozens of these, and some of these were in the slides that Kevin presented earlier. Lots of use cases, and a lot of it has to do with either really high data rate. So the first one, ultra short range communication, where you might walk up with a mobile device to a kiosk or something, and with a multi-gigabit kind of connection, download a bunch of content. VR headsets get talked about a lot. That may be competitive with the 6 gigahertz spectrum. I know there's overlapping interest in some of these topics. Office docking, or perhaps in your entertainment display. So in office docking, you might have a laptop and peripherals or displays. Same situation in your home, where you might have a TV that's wall mounted and want to connect it over a very short distance. And even for applications, we hear from other providers that are doing front haul and back haul type connections using 60 gigahertz. Bottom half, radar. The Google Solly technology is in the Pixel 4 is what I think most of us would call gesture recognition, but you can also simply do presence detection. Is somebody in this car? Are there people in the room? How many people are in the room? We even hear about aliveness detection. So you can see for like a car, for a safety thing, is there something living in the car that I've locked and shouldn't be in there? And I think in general, there's motivation, at least at CTA, we're seeing a lot of discussion around contactless interfaces. Voice, of course, qualifies, and we're well along that curve, but perhaps gestures and other techniques that can be enabled by radar. So that's the motivation here. Next slide. All right, here's the taxonomy of how we see industry working on it, and some of these names we know really well. So if you look, left side's communications, and we know this side really well, in part because of 802.11, both AD and AY and 5G NRU, both addressing 60 gigahertz communication systems. On the sensing and radar side, there are industry efforts, and what we see like with Google Solly, which is frequency modulated continuous wave on the right side. IEEE 802.11 AD and AY had already begun addressing the notion of what's called wireless LAN sensing, and they have created a separate study group specific to wireless LAN sensing. We're not spending a lot of time there, but the difference is there's a notion that you can use your existing communications networks and infrastructure to sense things going on in the room. So instead of fully dedicated FMCW radar, you use your communication systems or those components, for example, for security purposes or something, to know somebody's in a room. So that's what that part of the industry and that part of the standards development world is exploring. Next slide. Okay, getting more to the meat of the matter and migrating towards our recommendation. So the regulatory background is this: 60 gigahertz is band, what everybody calls 60 gigahertz. It's regulated in the rules in 15.255. These are unlicensed intentional radiators. So it's been around a while. There have been some tweaks to the rules. The specific section in question, for what we're calling personal radar rules, there's a term of art, the field disturbance sensors or sensing. That's in 15.255C3. So there are power limits expressed there, and I've listed them here. I won't read them off, but you see both conducted and EIRP power limits. There's also some rule related to use aboard aircraft. And so what's happened is there's been a number of waiver requests. And in particular, Google had a request related to its Project Soli radar field disturbance sensor. And the FCC has acted on that waiver request. And that's really instructive because, of course, there's a record there and people on all sides of that discussion weighed in. But we've also seen waiver requests from Bayer, Imaging, Leica, and Tesla sent in a waiver recently. It's been a month or two now, I think. But anyway, that record or these requests are coming in, hence where we're going with this recommendation. Next slide. So I didn't mean to put animation in here. Go ahead. One more again. One more. I think that's it. Just to talk about how the two systems coexist or not when they're put together. So in particular, frequency modulated continuous wave, the bandwidth, as I mentioned, determines spatial resolution. So you want really wide bandwidth in 60 gigahertz, at least for the Google technology. They wanted to get to 7 gigahertz to be able to resolve at finger scale, kind of finer details of a hand motion. And then it's clear to understand that if you're also trying to track motions like a swipe or something else, that's clearly going to be related to how frequently you're pulsing. So all those, the time and bandwidth parameters for the radar system matter. At the same time, if you're trying to coexist, we know 802.11, most of our systems, most of the wireless LAN systems today do some sort of listen before talk protocol, and they have channelization. So they take a wideband and operate in channels underneath that band so that you can put more devices or more stations in there. So what this little graphic is meant to show is you can see that if you have a listen before talk window and radar pulses, that's what the triangular, these sweeps are. So they typically sweep very quickly through the band that they're using, and then look for those returns to understand what is in front of them. So if those pulses land on a listen before talk in a band of interest, so this you can imagine that there could be, for channelization of an 802.11 type system, listen before talk, you'd have multiple of these channels along the vertical axis. So any of them could be interfered with if chirps are happening across that whole band. So you do need to have some windows in there where there's quiet, or just deal with this fact that one system's trying to be polite, one system's trying to pulse over a very wide band. Next slide. Okay, so the waiver request granted did three things. One, it dealt with power and after the record was complete, Google did not get its initial request, but it did seem to be that the FCC and the industry all arrived at a place that made sense for all the users of the band. So the EIRP you see was raised, conducted, and it mentioned a power spectral density. All those are part of that waiver request. To deal with this issue of fairness, they also noted, for the FCC's perspective, it's not fairness, I think. It just has to do with simply interference mitigation. But they did specify a duty cycle limit, 10% in a 33 millisecond interval. And lastly, that this waiver was not considered to apply generally to other field disturbance sensors. So what that means is it's a Google waiver. It does not automatically give permission to other systems to use those same parameters. And perhaps that more than anything brings us to these consistent requests to go ahead and do a proceeding to clear up this ban and allow use of both systems. Next slide. So we did have presentations, Google, Facebook, Intel, Qualcomm, all presented. Those companies, plus these others listed here in the second bullet, Infineon, Samsung, and Socionext, are on the record in the subsequent waiver saying, it is time to do a proceeding and let's get these rules in place, not do this by waiver. Next slide. Okay, these are the types of topics that came out in the Intel, Facebook, and Qualcomm presentations. So I just want to be clear, these are not, my next slide will be the recommendation. These are the subjects that at least some of the parties involved thought should be addressed. We're clearly not trying to write a proceeding or an NPRM for the FCC at this point, but you can understand the kinds of concerns that are being addressed here. The obvious one, should radiated power be greater for radar applications? That's fundamental to all these waivers, is the power limits as written are too low for commercially viable systems. So 2 relates to that same question. So do you just do for others what the parameters of the SOLI technology? And then 3, kind of the remaining points deal with, are there other ways to make sure coexistence works well? And that's the point of number 4 is just that. Do we do things in the radar applications that are similar to what the communication systems try to do? And therefore, if you do some sort of symmetric, if they're both polite to each other, should they just operate at the same power level? So again, these are just raised by people in the industry who are deeply involved in this process. Next slide, let's look at our recommendation. Okay, so from our group, we had consensus, no dispute on this. The recommendation is the FCC should start a rulemaking proceeding to examine 60 gigahertz rules, 15.255, to address these issues that have been raised. And the obvious topics to cover are the power levels for radar applications and coexistence mechanisms. So that's a more general framing of what we had on the previous slide. Let's see, that next slide, I think that may. Okay, so that's it. I don't know if we want to go back to that slide for just a moment. Sorry. This is, I don't think we're planning to take this subject up anymore. So we will repeat this as a final recommendation, but Kevin, unless you understand differently, I don't believe this recommendation is going to change. We're taking it to the bank, so to speak. So if that matters for your purposes, Dennis, whether it's considered now or in December, I'll leave that for discussion. Next slide, and then back to Kevin.
We just have one more slide. Next, please. Oh, so this is a summary of.
Yeah, you're not coming through well this time, Kevin.
I'm sorry. Brian, why don't you finish this out here? I don't know what's wrong with my microphone here.
Sorry, yeah, getting unmuted there. Okay, so some of the recommendations, and we can finalize these in December. The first one I just went over, so no change there. As Kevin mentioned previously, the co-chairs when we met, since spectrum sharing has come up in all 4 working groups, understandably, because obviously we're looking at unlicensed, the RAN, 5G and RAN people are looking at sharing because that's the way of the world now. And AI, a bunch of that is on sharing techniques. And then kind of to put one, really we dealt with almost in the first quarter, but every time we've looked at it, there's this question of should there be more detail and technical rules around unlicensed systems and coexistence. And I'd say the outlier obviously is coexistence, what we're asking for in 60 gigahertz. But in general, for the communications systems that have large ecosystems, we've always come back to the fact that the FCC's approach of letting the industry sort out and move quicker with the details of the access and the protocols and power levels. FCC continue to overall deal with mask and interference and power levels and let the details be worked by the industry. Next slide. And in our last quarter, as Kevin mentioned, we are going to do a bit more on spectrum sharing and more fully document the input we've had from a range of companies, end users like Boingo, SaaS providers. We've had a lot of good input there, as have other groups. We do need to spend a little bit more time on what area we haven't, I think, really dug into yet is what other techniques are there, what other use cases might be out there, or what other techniques, for example, have we fully leveraged freeing up spectrum for indoor applications? I think we've been focused on sharing and some other stuff, but perhaps, as is considered for the 6 gigahertz, there's spectrum out there that could be freed up for unlicensed use if you know that its interference to incumbents can be mitigated because, for example, you are using it only for low power IoT or only for indoor use. And of course, complete our final report. That's it. Next slide, but I think that's all we have.
Okay, then. Are there any questions? Not seeing any. And actually, it's very, very surprising that there wouldn't be. Again, it's amazing coverage of the area. There have been so many different areas that you have covered from with various companies and interesting and intriguing companies as well. So I'm surprised that there is not more in the way of questions coming in from the team, kind of watching out of the corner as is typical of many of you as well. 2 screens, so I put it on the big screen so I can see the slides, and so I have to turn the small camera.
Michael raised his hand. I don't know if that was, it's gone now.
Okay, Michael, so go ahead with your question.
Yeah, since the people are still kind of formulating the questions. So as you're going through your discussion on 60 gigahertz band, I think that the big shift is that our rules generally has been focused more on the communications, the broadband and so forth. the radars has been dealt separately. Now the personal radar, low power radar is kind of coming in and finding some niche applications. What are the senses you're getting from the people who are at your weekly meetings and providing presentations? That is this an area that we expect it to grow in coming years, or are these more of a unique applications and people still trying to figure out how that might actually perform and what kind of a benefit it will bring in? Where do you think it stands in terms of a technology or the maturity perspective?
Yeah, so that was definitely one of the things we heard a lot about, was that kind of the time seems to be right for both communication systems and radar. So, and I think because we see companies, in particular this coexistence, I don't know, working group, if you will, that companies involved in both systems are very interested in making this band work. So it's not one of these kind of zero-sum games where somebody is defending their turf entirely. They seem to be very cooperative because they want both to work. So, I mean, I guess we can look at where market data goes with actual deployments, but I'd say commercial interest is really strong. It does seem to be growing both for consumer electronics type applications, plus in things like WISPs and front haul and back haul, like we talked about.
Thank you, Brian.
Okay, very good. Our time has expired, but again, if there's well, there we go. Ron has a question too. Please, Ron.
Just very quickly, thank you. And I don't want to be in the way of lunch, the lunch break. So just a quick question for the group who have been meeting on this. I know the area of focus has been 60 gigahertz, but what is the state of the art, and has there been any thought in going higher in spectrum for the radar sensing applications, specifically above 95 gigahertz, and any experimentation that could be conducted in the higher frequency bands?
We've not heard that. Now, I'm sure they're researching. As we know, we've had past working groups that have looked much higher in frequency, so I'm sure that's come up before. And so I don't know if this is mostly just a commercialization, kind of a reuse thing. You know, it becomes cheaper to do these higher bands over time. So we've seen everybody move through 2.4, 5, et cetera, on out. Now 60 gigahertz. I think we have our skill set and our silicon pretty adept. That's a great question though. We can go back out. As you know, automotive has a band that it's using that's separate. So it might make sense to jump ahead to 95. We can ask some of these proponents if they are researching much higher frequencies, which again would free up. You'd have wide bandwidth, and perhaps for very short range stuff might make a lot of sense.
Yeah. So Brian, there is quite a bit of stuff on the military side at 94 and 140. Yeah, I mean, that I would say is pretty well worked out in some sense.
Okay.
Yeah. And then the other bands, I don't think you took a look at them, is, I would say much more academic, but there's a lot of work on the terahertz stuff.
Right.
Meaning from 0.1 to 1 terahertz.
Yeah, so a few years ago we did one. We looked, I can't remember the name of I don't know if it was Frontiers or which one, but we kind of looked, and really when we were up in that range, most of the discussion was about international rules, but nothing very tangible. I don't know if somebody's looking at it now, but it's one to keep exploring. I don't think anybody has it dialed in yet. And the rules, I mean, it's, as far as I know, it's possible to do. I mean, the rules permit, but it's been a few years since we looked at that ban. Our unlicensed, our current working group has not looked above 60, to be clear.
Yeah, so that may be an observation just to take a peek, because I know that since the Spectrum Frontiers work, there has been a fair amount, again, mostly in universities, I don't know, and military, but not much beyond that. All right, well, seeing no more hands, and given that it is already almost 10 past the hour, I think we will dismiss for lunch, and we'll conclude, or we'll reconvene promptly at 1 o'clock, but we'll, if it's okay from the FCC end, we'll leave the Teams meeting open so people can come back with their plate and interact. Those of you on the West Coast, you may want to have a late breakfast as opposed to having lunch on the East Coast. But we'll let you choose what the appropriate fare is based on your time zone. But again, great presentation, great work by both task force, or excuse me, both working groups, and really, really pleased with the progress being made. And we'll look forward to 2 more great presentations this afternoon. Thank you all.
Thank you.
Thank you.
Welcome back from lunch for the TAC members, and for those that are listening in through the internet. Good to have you with us as well. I hope you all had a good lunch. Several of the TAC members did, in fact, gather over lunch and did have a talk on all sorts of things, none of which had much to do with wireless or anything else. But well, I guess Dale brought us into one small conversation in that area. But in any event, let's get started. And Michael, if you could bring up the slides. We'll let Kevin and Tom take the lead on the 5G RAN Technology Working Group. So Tom and Kevin, take it away.
Okay, very good. Yeah, Tom's going to kick it off, and we're going to go back and forth. So go ahead, Tom.
Okay, good afternoon, everybody. Can you hear me okay?
Yes, very well.
All right, great. Thank you for the opportunity to speak to the TAC here. We're going to be talking about the 5G radio access network evolution. You'll recall this is a new working group, but we got kicked off in March, and we'll update you on several things we've been doing since our June readout. So the outline here, I'll be quickly going over sort of a summary of the charter members and some of the speakers we've heard from since the June meeting. We'll dive more, Kevin will dive more into the actual 5G RAN evolution. Just a reminder, our group is responsible for the RAN elements, including virtual RAN, but not including O-RAN. And then Kevin will also go into more of the advanced radio access network, some of the technology there, some of the different beam forming and beam steering and advanced antenna systems, including massive MIMO, which are very exciting. So even though we're after lunch and we're batting third up the batting order, you know, pay attention there because we'll have a quiz at the end. And I'll talk a little bit about some of the mitigating interference things that were in our charter and what we've been looking at, in particular with C-band multi-stakeholder group. And then Kevin will wrap it up with our work group plans for the rest of the year, including some preliminary recommendation areas. Okay. So just a recap of our charter, we're going to be going over the RAN architecture, some of the implications of that. We'll talk about virtual RAN, a lot of the technology evolution here. We're going to touch on, we've done a little bit of investigation to how propagation modeling tools can help with interference. We'll do more, and we'll talk more about some of these other areas through the balance of the year. Next slide, please. Okay, I'll pause briefly as I want to acknowledge, you know, with a new working group, having such a great group of team members has been very important. So we've had great contributions from all of these folks and their companies. So again, thanks for all your participation, and we've had great participation as well from our FCC representative and liaisons. So thank you very much to all of you. Okay, this is the list of speakers we heard from up to the June TAC. So I'll quickly just let you scan that one and we'll go to the next slide. Okay, so since the June TAC, we've heard from several important speakers. One topic was millimeter wave. We had a Verizon speaker talk about that, what they're doing with their millimeter wave deployments, initially for fixed wireless and then for mobility, and what some of the needs are there. We had Scott Townley from Verizon also talk about interference management and where some of the opportunities and challenges are with regard to that. I'll be talking about that more in detail. Kumar Balachandran from Ericsson talked about MIMO and beamforming, gave an extensive tutorial on taxonomy and some of the important information we'll learn from Kevin here on advanced antenna systems and how they work, and all the different variations of those types of antenna systems. And Kamran from the FCC has been kind enough to share with us some thoughts on interference management tools, things to think about as we go forward, because we'll need to think about that more as the complexity of problems in utilizing spectrum and sharing spectrum become more difficult. Ahmad Arman, Kumar, and Raj Sengupta from CTIA, so representing operators and suppliers, have been contributing in the various technical working groups on the C-band multi-stakeholder group, and we'll share more about what they're learning and working out in advance of the C-band auction that will happen starting in December of this year. And then we also heard from Google on initial thoughts on propagation tools and how they can help to minimize interference. So we've been busy since the June TAC, and we've got additional speakers that will be lining up over the next few months. Next slide, please. Okay, and I'll turn it over to Kevin for the next section.
Okay, thanks, Tom. The first part of our charter really deals with the evolution of RAN technologies, 5G, 6G technologies and architecture. I think we would have to admit we've spent most of our time on the 5G part of it as opposed to really getting into 6G, as a lot of the 6G stuff is sort of very aspirational and pointing towards use cases more than it is the actual technologies, with the possible exception of people looking at ever higher frequency bands and up into the terahertz ranges, was discussed in one of the earlier sessions. So we haven't really hit 6G hard because I would say we feel most of the information, concrete information about the technology evolution is available through 5G. But to put 5G into the proper perspective, it's kind of important to understand how the various last few generations of cellular technology have evolved. Underneath the enablers in terms of the technologies, the new architectures that have been brought in, the new spectrum that's been brought to bear, those have been sort of increasing in capacity and effectiveness over time, and then they tend to get bundled into the next generation because that's kind of where the next investment cycle is. And so many times these are things, there's a lot of things in sort of maybe what you might call advanced LTE or 4.9G or something like that, which are 5G type capabilities or partial 5G type capabilities. But those things, tend to catch the next deployment cycle, and so they tend to bend into these things. But the advance of the technologies kind of continues on a certain path. In terms of what the real optimization point or the real end goals for each of these generations is really quite different. So if you remember back to the 2G world, it was about increasing the voice quality and capacity and reliability. It was all about voice, but of course also using voice-like transmission capabilities also carry SMS, which turned out to be a very, sort of profitable kind of service, but the emphasis was really on voice and sort of voice-like transmission. With 3G and 4G, it kind of took 2 generations to sort of really get data where it kind of needed to be in terms of the usability. So the emphasis was, okay, continue to evolve the voice, but the real emphasis was on data capacity and also doing it in a reliable way. So 3G brought that about, but it was really 4G that I think cemented into usable levels. We kind of lumped those two together because we're both going after the mobile broadband space. Now with 5G, what we see is really much more of an explosion in the number of different kinds of things that 5G is trying to be optimal for. In fact, it's trying to be optimal for a wide range of different types of use cases, also pushing the envelope on performance to enable some of these use cases and then bring about the flexibility to be able to utilize all those things in the same RAN, even off the same cell site. So if you go to the next slide. So what this is an attempt to portray really the mapping between the major goal dimensions, if you will, and the many new technologies and architectures and spectrum being brought to bear in 5G. So it's not easy to put a picture like this together because a lot of these things are interconnected and they work together in combination, but of course some of them are trade-offs as well. But what we normally think of with 5G, the first thing that comes to mind is, ultra low latency, ultra high reliability in terms of enabling new use cases. That's kind of shown in the middle here. But it's also true from a performance standpoint that, very low powered transmission for low powered or long life IoT devices is also part of the pushing the performance, envelopes. And we also think of just massive scale of throughput. So on the scale side, but it's not just that, it's, how many of these IoT devices in particular can be supported, on the RAN. So what you can see here is that in the performance category, edge clouds, of course, are critical for bringing about low latency. Beamforming is important there, but it's very in conjunction with new antenna systems, advanced antenna systems, of bringing the overall scale up, not just for MBB, but for all types of use cases. And somebody can go on mute. Phone ringing. Okay. And so these are the things you first think about, but in order to be able to optimize the RAN for a lot of different kinds of use cases, you also need a huge amount of flexibility. And so that's where a lot of the features in the new radio design are there yet to bring about URLLC type capabilities, but also bringing about flexibility in resource assignment, in short, low powered transmissions, a whole host of things. And then in terms of flexibility, if you're going to build a RAN that terminates traffic at different points in the network, you also need to be able to bundle functionality at different places. And this is where disaggregation of the RAN and also the core functions, disaggregating those into different functions that can be located at different places, separating control plane from user plane. All of these things are critical for allowing this flexible mix of capabilities, and network slicing is sort of the capability that allows you then to isolate and select, which set of capabilities you're bringing about. vRAN is also an important thing just because that's that's the most practical way to do sort of RAN disaggregation, so it's closely tied to that. But in any case, and this is by no means a complete list of architectures, technology, and spectrum components, but these are a lot of the sort of heavy hitters for 5G. And I think it's hard to overstate how many new things are come together in 5G compared to previous generations. So if you go to the next slide, as an example, you could probably do this for all of these areas, but just to highlight one area of the URLLC type performance, and what you can see is there are many different components that come to bear on that. Probably the first level is the NR design itself. Many different capabilities with short TTIs and mini slots and preemptive scheduling, a bunch of different types of scheduling, grant-free, preemptive, semi-persistent. These are all levers really to allow you to use these in different combinations to try and match the needs of a particular use case. And we often think of latency and bandwidth and reliability as kind of these three things you have to trade off. The joke in the industry is, of those three, pick two, right? Because you're never going to get all three of them maxed out. But there's trade-offs between those, and all of these NR design capabilities, many of which are really new to 5G, will allow those, matching to those requirements with trade-offs in spectral efficiency and things like that. But it's what's required. A lot of these other areas contribute to that as well. I mean, beamforming certainly to be able to have robust links to end devices. Multi-connectivity is very important from a reliability standpoint. There's many kinds of multi-connectivity within the RAN itself at the core level, even between different types of RAT technologies. All these things are going to be critical to get well above the sort of 3 to 4 nines reliability you might see today to get into the 5 or 6, 7. Some people even talk higher reliability levels, but that's all going to require redundant air interfaces in order to achieve that. And then finally, the combination of edge clouds and disaggregation, network slicing, these are the things that really address the distance component of latency. So this is an example of how all these different parts kind of work in concert to bring about new capabilities in 5G. So if we go to the next slide. And I think I won't really cover this one for the sake of time, but as I'd mentioned, a lot of work on the framing structure and the numerology in 5G to allow a huge amount of flexibility in terms of getting very short slots and preemption of slots. And again, all comes down to flexibility. Generally, a lot of this is not needed for the early 5G deployments, which are primarily aimed at MBB, mobile broadband. But as the URLLC features are all standardized and implemented and deployed in the network, this flexibility is going to become extremely important. So if we go on to the next slide. So I'm going to switch topics here. In June, we kind of read out on the areas earlier, the component technology areas. We talked quite a bit about the deployment architectures, how vRAN, virtualized RAN fits into that. And those areas were covered fairly extensively in the first half of the year. We're not repeating any of that here. But once we had gone through all the component technology areas and the advancement of what areas were advancing more than others, at what kind of pace, then we really shifted to the kind of the meat of our charter, which is getting into the more dynamic forms of beamforming, beam steering, MIMO and massive MIMO, and the interference implications of that. So that's what we're really concentrating most of our time in this past session, as well as going forward, is in digging as deeply as we can into those areas, which are quite deep areas. So Tom had mentioned, one of the contributions that we had from Kumar Balachandran from Ericsson on our team was we'd asked to get a sort of a taxonomy of MIMO and beamforming, because I think the group needed to be level set on the various techniques that are used, but also just the naming, the definitions, and things like that. That's important to understand if you're going to go on then to look deeply at, what are the interference, challenges and potential recommendations in that area. So this is a very much capsulized summary of this in the next few slides of that, which I think is informative, and we wanted to go through this briefly. So to begin with, and some of this will be very familiar to some of you, but again, it's helpful, I think, to establish a sort of a baseline for other work, that you have it's really somewhat of a continuum between diversity techniques and sort of beamforming, beam steering, phased array type techniques. And these techniques have different applicability to the different bands, which we'll get into in a couple of slides. But essentially, in the diversity domain, you're talking about different channel modes between the end devices and the antenna, or between the antennas on both ends, and utilizing those different paths, those diverse paths, in order to increase signal level or even transmit different information. And generally, antennas that are set up for this, which you'd refer to as diversity arrays, have a distance between the elements that's much greater than the wavelength. By contrast to that, in the beamforming end of the scale, the phased arrays antennas have spacing which is on the order of the wavelength, and here the channel characteristics are quite different in the sense that each of the channels from the transmitter to receiver looks largely the same. So on this side, what you're really doing is you're getting an array gain, sort of focusing the energy in the direction of the device that you're trying to serve. There are also points sort of in between that sort of trade off between diversity and more beam forming type techniques. So if we go to the next slide. In terms of kind of definitions, there are a lot of forms of MIMO. So just a brief, almost terminology thing here. On the single user MIMO, side, you have basic, single layer MIMO, and the layer really refers to how many information layers there are passing through. So you have one information source, you're passing it into multiple antennas on both ends, and you're getting some diversity in the channels across there, which we're very familiar with. Multi-layer just means you've got multiple information feeds, and you're able to perhaps send different information over the different channel modes. And then when you go to multi-user MIMO, here you're really sending these different information simultaneously to multiple users, as opposed to sort of in sequence, as far as using the channel, the air interface resources. But of course, in 5G, we think of primarily massive MIMO as the big innovation that would be coming in. Not that it could only be used in 5G, but again, it's kind of an investment cycle type of thing. So essentially, the transmission method is essentially the same as MIMO, but except that you're using a very large number of transmit antennas, or antennas on the infrastructure side, and a smaller number typically a typically small number on the handset or end device side. So, but as the number of the elements grows, then you get this kind of averaging of the channel, and if you have much more optimal conditions, that is in terms of interference and being able to accurately characterize the channel, then you can achieve very high, essentially, spatial reuse in the transmission, and you can essentially kind of use the bandwidth of the whole channel to each of the terminals served. Now that's kind of in the optimal case, and we certainly had presentations which showed that normal field operation is usually pretty far from the optimal. And so what's clear is that you can achieve very high gains with massive MIMO, but you would not expect to be achieving it at all times on all locations. You would be achieving more modest gains in many cases. So it's not a panacea, but is a very important technique, and particularly in the mid band. So if we go to the next slide. As far as beam forming and sort of beam steering techniques go, there's three main types. This digital beam forming, which is the sort of the most powerful in the sense that you're feeding multiple information paths and have digital broadband processing for essentially each of your antenna sets. And this gives you a tremendous amount of control over the phased array. You can achieve multiple beams in a single time unit, and this gives you just a lot of control, and so therefore a lot of ability to handle sort of frequency selective losses, and take advantage of multipath. But it's also, so it's the most performant, but it's also the most complex, and with complexity generally comes cost as well. So high performance, use it where it really benefits. On the other end of the spectrum, analog beam forming is kind of the opposite, where you have a single digital broadband feeding an array of antennas, and in this case you're really only doing one beam per unit time per polarization. So it's a lot simpler in that you're not replicating the digital broadband many times, but you're not going to get quite the throughput you would with the full digital beam forming. However, it is relatively power efficient, relatively simple and economical, and that makes a lot of sense, particularly in the high band. And then hybrid beamforming is, as the name suggests, it's kind of a combination of the two, with multiple digital broadbands, each feeding multiple sets of antennas. But I think the key thing here is none of these are necessarily sort of the winner. You really have to look at them on a band specific basis. So if we go to the next slide. And then here, this is kind of showing if some of the previous things is applied to different bands. So on the left side, the traditional diversity type antennas that have been in the macro networks for a long time. In the mid band, you can really kind of trade off between the diversity and the array gain side of things. So as the little beams there kind of show, you can be taking advantage of multipath and the array gain at either same time or trading off between those two, depending upon the channel characteristics between the two. Once you get to the high band above 6 gigahertz, however, then the channels tends to really favor line of sight transmission. So in other words, you're really counting on just a one dominant mode, typically, you know, the direct mode. And so therefore, you're getting all of your gain really from the array gain. And so in this case, analog beamforming makes the most sense, especially given the very large number of antennas that you may use here, and the fact that these at the high frequencies, these may be cells may be spaced fairly close together. So lots of cells, lots of antenna. That's a lot of digital baseband if you were to try and do full digital processing. So Dennis, I know you particularly were interested in sort of the combination of millimeter wave and you know, massive MIMO beamforming, but it doesn't look like it's in the near term, you know, roadmaps for anyone. So if you go to the next slide. So just to summarize a little bit on this topic at a high level, the benefits of MIMO, massive MIMO, and beamforming, beam steering are significant in terms of capacity, spectral efficiency, you know, coverage gains, and really for millimeter wave, really making it practical to use millimeter wave, given the propagation characteristics at those bands. It also really brings a lot of these degrees of freedom for optimizing RAN performance. And I think, you know, this may take quite some time to really fully leverage all of those things when we start thinking about interference mitigation and coexistence and things like that. There's a lot of possibility there, but also an awful lot that would have to be sorted out as well. We're going to talk about that more later in the talk. The challenges, the corresponding challenges, are the degrees of freedom mean much more dynamic power distribution and the channel conditions, and you can, you know, cells may not, you know, just overlap at the edges. They can really intrude into across coverage areas. That can be an advantage, can also be a real challenge. So it does complicate the measurement of radiated power and how you model both in-band and out-of-band interference. So that's a big topic, and we're going to see, you know, how far we can carry that in the last part of the year. But it's a big topic, and we're certainly not the only group looking at that. We want to leverage other groups that are working that as well. I think I'll skip the recommendation areas because those are really covered at the end in our summary. So rather than repeat those, why don't we go on to the next slide, which I think is I'm going to hand it back to Tom.
Yeah, thanks, Kevin. We got a little echo there. So briefly introduce interference taxonomy. Is everybody else getting a little echo? Okay. There was help provided by Dale Hatfield, so we'll talk about their significant benefits to kind of having the lay of the land here in the verbiage and how we're talking about this stuff. And I'll just skip to the next slide to kind of begin that overview that Dale provided. Can we go to the next slide, please? There we go. So this is kind of a high level, focusing on the wired communication networks and the physical layer as opposed to the upper layers. You have both man-made and you have, of course, natural interference. And if we go to the next slide, it shows that these are traditional types of interference that we talk about. So we talk about both in-band interference as well as out-of-band interference. So when you're in-band, you have co-channel and adjacent channel, and you have out-of-band emissions near the band edge and those that are farther from the band edge, excuse me. We'll utilize some of this as we talk about the example that we've been looking at. Go ahead and go to the next slide, please. And many of the working group members are also part of the C-band multi-stakeholder technical working groups. So this picture is important because it sort of lays out how the C-band will be allocated. And keep in mind, we're talking about cleared license spectrum that's currently utilized by the satellite community, but not heavily utilized. So they'll be able to, if we could click on that. Thank you. So you've got the CBRS spectrum from 3.55 to 3.7 gigahertz below the C-band. And then you've got the C-band starting at 3.7 going up to 4.2. And then you've got altimeters operating above that at the high end. So, after the auction occurs and the satellite operators conduct their repacking, essentially, they'll be moving upwards in the band and occupying the upper 200 megahertz, leaving a 20 megahertz guard band and 280 megahertz for terrestrial. That's flexible use. We labeled it as terrestrial 5G because that's the current framework that we're thinking about, but obviously could be used for any wireless technology there as appropriate. So there'll be satellite community will be repacking, retuning, putting in filters on earth stations, and moving their content and their content providers and carriers into that upper 200 megahertz in 2 phases post-auction. Okay, on the next slide, please. So we're talking about that 280 megahertz, and we had a presentation from Scott Townley of Verizon, and some of the things that they've been looking at to help mitigate some of the interference. So primarily, you're thinking about here. There's over 15,000 deployed earth stations, and when we start deploying terrestrial wireless into this, namely 5G in this case, this 5G signals have the potential to interfere with those earth stations, but they can also be mitigated. As I mentioned, they'll be putting in filters at the earth stations. So at the input, of course, we can filter out much of that, and of course deal with out-of-band emissions by limiting, by creating limits on those out-of-band emissions. Also, the different antenna types, some of which Kevin talked about just moments ago, can provide different opportunities. When you're thinking about these massive MIMO antennas with 64 by 64 elements or 32 by 32, they can provide certain opportunities. That's sort of one category, if you will, of antenna type. And then you've got your beamforming type antennas, and then you've got SDMA antennas, which also are equipped with remote radio heads. So in general, you can utilize some of those different beamforming technologies to either omit beams or reduce power in certain beams to minimize the interference. And I think the table also summarizes kind of what some of the opportunities are. So you've got the blocking, and with the those massive MIMO antennas, generally none's needed. You just utilize distance, and you've got the filters on the earth stations, and then like I said, you're using distance, and then you can also with the mobiles or the UEs, you utilize power control capabilities. And interesting enough, even though you want to keep generally cells a certain distance from the earth stations, you could also deploy a small cell will help to limit the power from coming from the UE by utilizing power control. And there's also the ability to either omit or limit the power on beams. When you drop down to the beam forming, you can use distance and filtering. And you can also utilize power control on the UE as well as small cells. And similarly, with SDMA, although you also have the ability to do beam omission. So these are some of the things that Verizon has identified. And as we go further into this, we'll continue to look at the different opportunities for technology to mitigate, as well as process and methods. So next slide, please. So since the C-band order came out earlier this year, it called for a C-band multi-stakeholder working group. And this is summarized on this one slide, but there's represented over 60 companies. Associations are represented, including the aviation community, a bunch of folks in the wireless community, including broadband and CBRS members, broadcasters, filter companies, programming companies and content companies, satellite operators, clearly, along with wireless service providers and manufacturers of network equipment. There are 4 main technical working groups, 3 of which I'll talk about in a little bit of detail. Technical Working Group 1 is working on terrestrial, wireless, and Earth fixed satellite coexistence during and after the transition. And then the second one is how the Earth stations are relocating to the upper portion of the band. So I won't be talking about that in this context. The third, TWG3, is looking at coexistence between terrestrial wireless and the aeronautical or the aviation community equipment. And the fourth technical working group is looking at the coexistence between terrestrial and the C-band, as well as in conjunction with the CBRS, which is immediately below it. Okay, next slide, please. So on technical working group 1, the 3.7 order specifies limits on the receiver, the Earth station blocking, and on out-of-band emissions. And we kind of touched on some of the things there that that the group is looking at, utilizing Earth station filters for the lower part of the band, setting out-of-band equipment limits, utilizing beam forwarding, beam steering, and possibly beam omission, and then also deploying, where appropriate, a 5G small cell to utilize power control to limit the power of the UE. So these are some of the things that can be used to prevent interference. The group is continuing to look at ways to detect and mitigate interference, as well as how to measure it, and then resolution processes as well. Okay, I kind of skip over the TWG2 and then go to TWG3 on the next slide. So terrestrial and aeronautical. So if you recall from that earlier slide on the C-band, you've got the C-band being sort of cleared out at the lower 280 megahertz, but then about 200 megahertz above that, you've got aviation industry utilizing different sorts of radar altimeters to conduct their operations. So the group is studying and working with the aeronautical community to assess the equipment performance of those different radar types and altimeters, studying the interference cases and evaluating the use cases. Initially, most altimeters seem to be adequately protected. There's a new report that was issued by the aviation community last week, and the community is diving into that, and we'll be evaluating that and looking at assessing the risks and the opportunities as we go forward. And then the last TWG4, the next slide, please, is looking at coexistence between the C-band and the CBRS band. So this is the band that's immediately below the C-band. So some of the things that they're looking at are, since most of these spectrum is planned to be used in a TDD mode, they're studying TDD synchronization, whether it could be some types of synchronization. There's sort of full synchronization as well as semi-synchronization, where you're looking at how to utilize the frame structure or part of the frame structure to be similar, at least, sort of being the good neighbor. So neighbors sitting next to each other in adjacent parts of the band could possibly utilize some forms of or partial synchronization to minimize interference between the bands. We're also looking at out-of-band emissions impacts, receiver overload issues, and some of the agreements that have already been set up in the CBRS Alliance for TDD synchronization and coordination. Excuse me. So there's a lot to build on here. The group is working on different aspects of this, trying to maintain enough flexibility to make sure that people can utilize the band the way they see fit, but also to make sure that they're minimizing interference between users within the band and with the adjacent band, which is the CBRS band. Okay, next slide, please. Okay, I'm going to zip through this really quickly because I want to leave time for Kevin's slides. I know we're running short on time. We also looked at optimizing communications by considering propagation. Basically, some of the existing models rely primarily on terrain modeling, and they don't take into account things like buildings and foliage and so forth. So we had a presentation from Google that talked about how to do this. Next slide, please. This basically indicates that, if you can look at some actual real-world usage models, there's opportunities for utilizing the spectrum more efficiently. Can you go to the next slide, please? And Google's main thrust was that if you utilize capabilities like machine learning, which obviously the first group talked about, lots and lots of data at nanoscale. You can look at, basically having data on buildings, terrain, and foliage, as well as crowdsourcing techniques. You can help to optimize this and have more accurate real-world measurements, and utilize that to improve your propagation modeling and how far your signals are going to travel and how much capacity you'll be able to provide and so forth. Okay, next slide, please. Okay, and these are some of the things that we'll be looking at as we go forward in identifying sources of interference. And I want to pass it back to Kevin here. I think the next slide is, you can go to the next slide, please. Okay, I'll pass this back to Kevin on our potential recommendation areas and next steps.
So better go off mute then. Yeah, that last area was an area that has been introduced lately in terms of unique identifiers, perhaps being built into transmission of at least new systems going forward as a way to better identify sources of interference. So that might well be an area where there might be some recommendation, although I think it would be more applicable to new rather than existing systems, which would be hard to retrofit. So to kind of summarize, the way we put this, potential recommendation areas, and I guess the way I would sort of categorize how we've gone through the year is, as we had laid out at the beginning, we were going to look at all the different technology areas, try and look end to end, implications on interference, and then really dive into then how could things be improved or interference better mitigated through, well, whatever techniques or technologies could be applied. So I think what we've found is it's a pretty deep topic area, and so we're narrowing down to the areas that we feel are the most important, would have the most impact. But we're maybe not at the point where we're sure there's a actionable recommendation for the FCC in particular. There may be industry directions, and there may be things that the FCC can do to encourage those, and there may be direct FCC action that could apply there, but we do need to understand those areas a little better. And we are trying to leverage, just like the multi-stakeholder group for the C-band, we're trying to leverage work that other groups are doing, because many of those are quite deep expert teams working those issues that we would not want to try and duplicate, nor would have the time and resources to duplicate. But to kind of match the areas that we covered today, having to do with the advanced antenna systems and beamforming, the interference mitigation, and more dynamic spectrum management capabilities, these topics are not mutually exclusive. They're somewhat overlapping and intertangled, but in the kind of beamforming area, we're really trying to look at this from the perspective of the challenge side of that, around measurement of power, and better modeling of the propagation for better managing interference and coexistence. And so those are areas that we're going to be spending more time on at the here, trying to wrestle those down to recommendations. In the interference mitigation space, we're trying to take some of the near-term work, like we heard from Verizon and the multi-stakeholder group work, and those a lot of that's been focused on the mid-band, and think about that from the perspective of how much that might be applicable, or at least the approaches be applicable to other bands. And specifically, we had prioritized the mid-band this year over or the work in the last semester, if you will, on the mid-band because of its more sort of immediate application. Not that millimeter wave isn't being deployed, but there's a lot going on in the mid-band space right now. Millimeter wave, of course, is just going to continue to grow in importance as the scale-up needs and densification becomes sort of more front and center. So we'll be shifting more into the millimeter wave space, but we want to try and see how much what's the concentrated work on the C-band now could be applied to the other bands. And we think that the synchronization topic is going to be a very important one. And of course, that depends a lot upon, whether you're talking about in-band and out-of-band techniques. But with TDD, synchronizing when you're transmitting from the high-powered, antennas, so that you're not essentially blasting the lower powered transmissions from the handsets is a critical area, and so we expect to be spending a fair amount of time on that. Probably the most sort of exciting or promising area out of all of this is the opportunity side of the dynamics. So, and we kind of characterize this at two levels. One is using the more finely granular models, much more data, crowdsourced data, leveraging AI and ML to do better characterization of the interference, so that we can make sort of more intelligent rules around the power levels, or when power levels need to be reduced, particularly in kind of sharing bands. But also, long term, can there be proactive real time or near real time closed loop interference mitigation by having these much more accurate models, and models that have been sort of proven in with a lot of real world data collected from many different sources. So that's a very promising long-term area, and we certainly hope to be able to make some recommendations in that area for how to move sort of that ball forward. A lot of things will have to happen before that becomes a reality, but what needs to be done, in the near term in order to move us closer to that reality. So next slide, please. I'm just showing this. We used this graphic last time just to show the areas going forward. Interference management is still very much sort of front and center, maybe applied now more heavily to the millimeter wave band, since we've been hitting the mid-band the hardest. And then one topic area that we treated is kind of a second order topic area, but we want to make sure to cover. It has to do with front haul technologies and being able to densify the front haul. And so that's an area we want to make sure to fill in. If you go to the next slide, which I believe is the last slide. Heavy hit on millimeter wave. We will hit front haul maybe as hard as it needs to be hit. And then the other area that is an area that we've not spent a lot of time on yet is sort of ramifications for equipment authorization aspects, which is one of the charter questions. So that's an area for us to open up. So front haul and equipment authorization are sort of topics we'd be cracking into. I expect we'll be spending a good part of our time on the interference challenges for sure. And then, of course, firming up our conclusions and recommendations. So that's it for our readout.
That's great. Another very dense activity, given the amount of information that you've been able to collect and the number of people that you've heard from and all the rest. So it's really, really terrific. Once again, I'm waiting for those hands to be raised and questions to be answered by the co-chairs. A remarkably quiet group today.
Well, this is the after lunch slot, so.
Yeah. And we are, I will comment that each of the groups has successfully exceeded their time limit, so we have that going as well.
Dennis, I'm trying to raise my hand, but somehow.
Oh, don't worry, just talk. Go ahead, Marty.
Okay, thank you. Kevin and Tom, it was really a fascinating presentation, especially about the MIMO. But I just thought I would get on my soapbox again and remind everybody, first of all, that even though we've gotten the habit of talking about beamforming, in the case of spatial division, multiple access, you really don't have beams. What you have is the combination of these signals in space, and you really end up with a sphere or a football in space, which and the only reason I bring that up is it's illustrative of the level of efficiency that you get with spatial division, multiple access. And for the same reason, even though you're usually correct, Kevin, that digital spatial division multiplex is more complex. And when you do have multiple channels, you end up getting efficiencies that more than make up for the cost. So this has been demonstrated in lots of systems that you end up with a lower cost system, even though there's much higher complexity. So, but thank you very much for that great presentation.
Oh yeah, I certainly didn't mean to denigrate in any way digital beamforming. It's a really important technique. Although I think I just worry sometimes people think that it's sort of the silver bullet, and its applicability, of course, like all of this stuff, there's trade-offs. So it has more applicability in some bands than others.
No, I think you covered that very, very well, and I think provided, and I've been attending some number of your working group meetings, so that the clarity has increased over time. Marvin, you are up with your hand, so please.
Yes. Tying together the last two presentations, what is the applicability of this to unlicensed uses?
Well, I think the
especially the stuff on beamforming and diversity.
Oh, you mean applying that as a technology to unlicensed?
Yeah.
Well, Kevin, you want me to jump in here? This is Brian.
Yeah, go ahead.
Well, I was just so one of the things I forgot to mention in my presentation is, as we've gone through this year, I was surprised at how much technology sharing is going back and forth between the wireless industry, the kind that Kevin's dealing with, and then the unlicensed side. I mean, the techniques that we see showing up in 802.11 of putting a lot of stations close together, densification, and using, people may have different terminology like puncturing and doing different techniques. And then clearly we're doing beamforming for 60 gigahertz. So there is lots of sharing. I think it happens at different rates and different purposes, probably because the bands are a little bit different and the cost structures for the equipment are different. But I don't know, I just see lots of the academic techniques flowing into both sides.
Well, I should also point out that there's a huge amount of what we call beamforming in Wi-Fi. So that's almost every Wi-Fi system is now uses some form of beamforming.
All right. Any other? Oh, Greg, you're up. Go ahead.
You're on mute.
That do it? Ah,
Yeah,
okay.
did it. Go ahead.
I thought I'd add to that last chain of comments that as we're talking about going to higher and higher frequencies, what we learned in past years is that the beamforming and the directability gets more and more exact. And in fact, we saw a speaker who went up to terahertz was actually talking about lenses. He was likening his beamforming to light, to the lenses used in light. And the sharing gets more and more efficient as you can do that.
Good. Any comments on that, Tom or Kevin?
You know, it becomes more efficient, but then you also need to be able to control it, right? Because you know, the big array gains, you know, give you the power to place beams and place the power, you know, where you want it. But when you've got completely different systems, you know, it remains to be seen. You know, how can you have the multiple systems not you know, hitting each other even harder than you would under normal, maybe isotropic or typical diversity antennas. So, or, you know, really the open question is, how much coordination would you need between these different systems to allow you to get that kind of efficiency that you really want?
That's what standards are for.
But I think Greg's point is well taken. Is, you know, as you go higher in frequency, a lot of those you know, signals are traveling in much smaller, you know, much smaller paths, so that there's less likely for interference, and that can help to manage it. Yeah. So thanks, Greg.
And the overall, the geographic spatial reuse is very high, of course. Yeah.
I think we are going to have to transition now to our last speakers of the day, the special Brian and Russ show. So if you could bring up the slides, Michael, we'll move on to our last of the 4 sessions. And Russ and Brian, please take it away. Russ and Brian, you're going to have to unmute yourselves.
I hate when that double mutes. So yeah, as I was saying, this is the third quarter readout for the 5G IoT and Open RAN group. With my co-lead Russ and I will give the presentation. I'll begin and then hand it off to Russ in a bit. So we can go to the next slide, please. So just to highlight an outline of what we'd like to cover today, we'll go through some of the details of the working group participants, review the charter that we had, and also give a summary of the subject matter experts and topics that we covered this past quarter. I'll then go through a standards update, and now I'll turn it over to Russ to go through some key observations, potential areas for recommendations, and finally a request for input. Next slide, please. Again, like to give a big thanks out to all the working group members that have provided information to us and you know, have had very good discussions along with the speakers and invited guests that we've had. Certainly the FCC liaisons have been a big assistance to our working group as well, and we do value their input and contributions to the working group. Again, if we missed anybody, please let us know, but I think we caught everybody on that slide. I'm just going to go through the highlights of the charter, again, in review of what we were looking at. In the area of 5G and low, mid, and high frequency bands, looking at information on the development or deployment of technology, how scalable the approaches are and what timeframes to be anticipated, how can XRAN help large and small companies, some of the key challenges of disaggregating the network, testing and deployment, as well as how will the evolution of the network evolve and keep pace with the ever increasing bandwidth requirements. Other topics we're looking at include 5G services over the millimeter wave bands. How can 5G coexist with Wi-Fi? The status of the deployment of services by verticals. Looking at dedicated or shared spectrum and see if that can help support applications such as industrial IoT, as well as other communication and technology trends. Next slide, please. So again, I'm not going to read through each of these, but we had a number of speakers that we've had during this quarter. We had Ericsson give us an O-RAN Alliance deep technical review. Dr. Brenda Connor came in and talked about some of the RAN programmability and through the near real-time and non-real-time RICs and the value of that. We've had Prabhakar come in from the Small Cell Forum and talk about how the SCF has a history of disruption and driving openness across small cell networks and how to enable verticals to build and use macrocellular networks. We had Analysys Mason come in to talk about U.S. Spectrum Report findings, as well as including the plans for mid-band spectrum and report with some actions and calling the U.S. mid-band spectrum low, as well as looking at the other mid-band spectrum areas such as 3.45 to 3.55 that'll drive faster deployments. Next, we had the Power Project Office come in, talk about RAN slicing and how the NSF and Power and Coliseum projects are looking at open architectures, algorithmic frameworks, test beds, and measurements, and some of the proposals that they're looking at going forward. Qualcomm came in and talked about unlicensed new radio, the 5G new radio. Overall, and specifically looking at 3GPP release 17 and what's being put in there. Again, synchronization is the key enabler for more efficient sharing of the spectrum, and synchronous allows priority-based channel use for mobile scenarios. We had my alma mater, Arizona State University, come in and talk to us about Smart Campus and IoT. And how they're leveraging 5G for production and research needs and looking at city scale projects. Let's move to the next slide, please. Continuing on, we had Qualcomm come in and again talk us about narrowband IoT and RedCap, looking at what they're doing in 3GPP release 17 and what the goals are to reduce complexity and cost through device constraints. Addus came in and talked about some of the work they're doing, looking at future needs, including 6G, which is expected to launch as early as 2028, looking at the smart connectivity systems as a platform for the next generation internet, and various use cases that are being looked at as part of 6G. We had the working group team discuss CBRS auction results and next steps with the observations that large service provider presence in the CBS PAL auction and a very limited number of bidders from enterprise and industrial. Google came in and talked to us about spectrum sharing, and they looked at in-depth into model propagation with ML. As well as geodata and crowdsourcing, and it's time to move from trusting analysis to trusting real data. And the current models support inefficient spectrum use and efficiency. We had a presentation and white papers on 6G from the working group team, looking at the worldwide focus on 6G planning and creation of a framework, as well as some of the 5G topics that are going to spill into 6G, including AI as being one of the fundamental technologies. We had Greg Lapin and CTIA and Cisco talk to us about the EIRP and 5G safety, looking at some of the targeted changes to the Commission's rules on exposure to RF publication of IEEE 95.1 standard, as well as publication of additional guidelines. Let's move to the next slide, please. Next, I'd like to dive into the standards and consortia updates. So if you move to the next slide. So again, COVID-19 has had, continued effect on 3GPP and industry standards meetings in general. There's a consensus now that the 3GPP meetings are going to continue electronically at least through the first half of 2021. And there's even some mentioning that that's going to continue for the entirety of 2021, just because of the logistics of getting back to a norm of face-to-face meetings on a global scale. The continuous meetings are reducing productivity and increasing overall fatigue on the process and its delegates. They desire to have only 6 working group meetings, but when you do that and the working group meetings extended to 2-week electronic meetings, it means you're almost continuously preparing and being involved in conference calls and meetings. So there's a never-ending cycle there. And how do you vote in electronic meetings is still a process that's being under development by 3GPP, and it's planned to be ready for December. And this is important because in March of next year, there are the specification groups have their elections for their leaders, both chairs and vice chairs. So having a process in place is going to be important for them. The U.S. participation in a COVID environment, one of the things we've heard anecdotally is that attendance from U.S. companies at 3GPP meetings isn't as great as some of the other regions because of the cost of travel and so forth. So one would think that as we move to a virtual environment, that we would see increased numbers of participants. And certainly we do see this, and we're going to research the numbers and have those for the end of the year. But we do note that there is an increased number of participants, not only from the US, but also, and a bit worrisome, from other regions of the world, especially China. So they're taking advantage of the fact that virtual meetings allow some of the smaller companies to participate, and that increases the numbers of participation. And the reason why this is important, it goes back to the last bullet I mentioned on electronic voting. Who actually has the voting rights in these elections, and that could influence, everything from who leads the groups to who's going to set the stage for what gets into the various releases. So that's an important point to bring out. The good news is Release 16, those were completed during the last working group meetings, and everything is stabled and were ratified at last week's plenary meeting. So Release 16 is pretty much a done deal now, and the books are closed on this. But if we move to the next slide, Release 17 is a totally different story. Because Release 16 was really a long way into development before COVID hit, that's why we were pretty much able to keep Release 16 on target. Release 17, however, is starting from scratch in a COVID environment. So that puts us at a bit of a disadvantage as far as getting this thing done on target. Right now, there's an expectation there's going to be a 6-month delay. There's also some that say there'll be a 9-month delay in Release 17. It's clearly going to be in the first half, if not the second half of 2022. Given that and the increasing likelihood that there's going to be e-meetings throughout next year, it's likely that Release 17 is not going to be complete until the latter half of 2022. In the December plenary meetings of 3GPP, there's going to be a detailed plan that's going to be presented. So we'll find out more at that meeting. And that unfortunately is going to happen after our last TAC meeting in December. So we won't have those insights for that final meeting. Also, the concern is of downscoping of the releases possible. There was a lot of discussion on multicast broadcast related work and whether that should be in or out of release 17. This is important. For example, FirstNet needs MBMS in 5G release 17. Fortunately, right now, as of last week's plenary, it's still in there, but there was a lot of concern on downscoping, and we still may see further downscoping as the pressures of COVID-19 impact the electronic meetings and the content and schedule for release 17. There was also another issue last week that came up regarding including band N96, which is the 6 gigahertz into requirements into the 3GPP specs. And there were firm objections from the Chinese on including that. And it was really a roller coaster ride at the last week's plenary meetings. Even though it's a regional requirement, it was clearly a political blocking by the Chinese to try to push those requirements out of release 17. However, after last week's plenary and the negotiations back and forth, finally the Chinese backed down, and we did manage to get new radio 6 gigahertz band N96 will be part of the specifications. Next slide, please. Release 18 is also out there, although there's no timeline on release 18. There is initial planning underway to try to identify some of the feature content for release 18 and initial studies underway. Again, I'm not going to read this list off, but just suffice to say that, you know, there's many things that are being discussed. The door is not closed to the feature content on release 18 yet, but you know, with release 17 uncertainties and the clear uncertainty on when release 18 will happen, you know, there's still opportunities that this list will change before release 18 is finalized. Next slide, please. So switching gears, looking at Open RAN and Small Cell Forum. The FCC did host a all-day forum on 5G Open RAN, and I believe that's also available for playback if you hadn't had an opportunity to view that. It was focused on the development and deployment of Open RAN and expected impacts to 5G technology. So that's a good resource to go look at. It was held last week, so it's fairly fresh. The ONF, Open Network Foundation, also has announced a new 5G SD-RAN project. This is a software-defined radio access network open source platform, and it's based on the O-RAN Alliance architecture. So they will use an open source near real-time RAN intelligent controller that's defined by the O-RAN Alliance and consistent with the O-RAN Alliance architecture. And you can see the founding members there, many of which, if not all, are part of the O-RAN Alliance itself. Finally, the Small Cell Forum has published a couple of documents which are of interest. First is the options for indoor cellular, which is a document to assist building owners and tenants in solving the issues of poor and substandard cellular connectivity on their premises. So that's, again, a good document that building owners can use to understand some of the challenges and also how to address those challenges. The next is the Market Status Report 2020. This has several interesting conclusions, including indoor and enterprise small cells will be far larger market than urban small cells for the short term. Urban small cell networks will be slower to get to large scale due to many stakeholders' need for a common benefit. There's also complexities of siting and approval regulations, as well as macro networks often deliver good enough performance outdoors versus inside buildings. And finally, the rollout of urban small cells is hampered by access to sites and approvals, but automation could be key in reducing costs. Next slide, please. The ITU also is looking at several things. The radio sector within ITU is looking at incorporating 3GPP Release 17 specifications into their IMT 2020 specs. So once those are done, the evolution of IMT 2020 will include Release 17. There's also a draft new report on terrestrial IMT for remote, sparsely populated areas to provide high data rate coverage. And also they've started the future IMT 2020 vision for beyond 5G in order to stimulate global research. Now notice they don't say that's 6G yet. And in fact, ITU doesn't use the G terminology. That's something more invented by the industry and standards bodies. But they are starting to at least look at the first steps leading to the next IMT, and whether that's 2030 or some other date, that's to be seen. And they also are looking at a technology trends report, and this again is targeted to be complete in 2022. It's also interesting to note that the ITU-T Study Group 17, which focuses on security, they recently completed a preliminary step of creating a 5G security standard, and this is based on the Korea Internet and Security Agency response to attacks on 5G core networks. And they've included procedures for verifying integrity of 5G communication, as well as denial of services through forced non-encrypting and stealing voice information and forgery of communication contents. There's also proposals that have come into Study Group 17 on quantum cryptography, blockchain, and vehicle security, as well as 2 proposals on personal information protection and cybersecurity failure responses. Next slide, please. This slide lists the 5G deployment updates as of September. Again, I'm not going to go through this in detail, but as you can see, nationwide coverage here in the U.S. has been achieved by both AT&T and T-Mobile. Verizon is, with 36 cities deployed, and plan more than 60 cities with mobile and 10 cities with fixed wireless by the end of the year. And we see other carriers here in the U.S. also deploying, as well as a growing availability of 5G devices. Worldwide, again, we're seeing countries throughout the globe deploying 5G. And again, I'm not going to go through these in detail, but they'll be here in the presentation for your review. Next slide, please. Open RAN market status. Again, looking at the estimated total worldwide deployed sites is approximately 7,000 to date. The operators are listed in the left-hand column of this chart with the various radio access technologies listed on the right. You'll see many of these are still on 4G, some going back even to 2G, although NTT Docomo has a pre-commercial trial system with 5G. The other thing to note is that to date, these are not based on the O-RAN Alliance specifications. Those are still fairly just coming to the market and just being available. So most of these are pre O-RAN Alliance specifications based, and majority of them, as you see, are based on Open RAN, with some of them based on non-Open RAN specs. Next slide, please. So at this point, I'll turn it over to Russ to continue as we move into driving points and observations. Russ?
Thank you very much, Brian. Can you hear me?
Yes.
All right. I'm wearing my 5G hat. We take this very seriously in the working group. So I'm going to cover some of the key points that we picked up throughout the summer session, as well as the potential recommendations we're headed towards. So one of the top areas we've been tasked with is looking at O-RAN, Open RAN deployments, the timeline, the adoption, scalability, some of those issues. I think everybody's familiar with all the opportunities that O-RAN can bring in, and that's created a huge market momentum in terms of the innovation, the potential cost savings. Rakuten is saying they're saving anywhere from 40 to 45%. Also, the competitiveness that creates, how the disaggregation is opening up a lot of new software opportunities for companies coming into this space. However, we have to point out it's not all roses at this point. There is a big difference between greenfield and brownfield. And, companies I mentioned like Rakuten that are deploying or greenfield, it's fairly simple. For legacy environments, it's fairly complex. So there's a lot of system integration, interoperability concerns. There's less power efficiency in general, potential interface conflicts within the O-RAN environment. Also, the need to have legacy support in terms of a network, and potential security with all those different players involved. So this is an evolving situation, and we're going to probably have a little better readout in the fourth quarter. If you could go to the next slide. I do want to state, though, that this movement continues to grow. For instance, the O-RAN Policy Coalition was just stood up probably 3 months ago, and we did our first report in June. This slide's already out of date. It was just made last week. I believe there were 2 new members. So they're roughly at about 55, 56 members. And their goals are really to support this global deployment, also signal government support, government procurement, which will help drive some of the adoption of O-RAN, fund some of the research and development, remove barriers. By the way, they're having their meeting this week as well, so it'll be interesting to see what comes out of that. Next slide. So we've taken a good look at IoT verticals, and we've got a deep dive, some more work to do on some of these verticals. As we start to dive into these, each vertical seems to have different requirements or needs. Also different, I would say, deployment and use models. You've got different viewpoints from those people, like IT/OT operators of, I need a public network, I want to have a private network. What are the latency needs, particularly in industrial IoT? Some are really pushing more for the compute at the edge. As you look at some of the control loops, again, in industrial, for instance, and transportation, you have very low latency, so it pushes compute out to the edge, very tight QoS, ultra reliable, low latency, TSN type capabilities. There's also some concerns about reliability. That includes both network and power. Then the security itself, there's various layers of security, data privacy, throughput, et cetera. So you're starting to see, rest of the world, we've seen a little bit, I would not say rest of the world, but some of the leading industrial company or countries out there are promoting private spectrum. So we're taking a deeper dive and looking at this as, when we get to potential recommendations, what that would look like in terms of potential models in the United States or locally licensed spectrum. By the way, we do expect to leverage some of the work Addis has done on characterization of IoT devices. Next slide. This one I am not going to read to everybody. There's a few very key points, though, that I want to bring out. As we get to deeper down this path of 5G and into 6G, especially as we start to get into millimeter wave, and as we thinking about 6G even, the call out in 6G is much more millimeter wave, even terahertz spectrum. So what this really leads to when you start to equate this to number of antennas to support base stations, et cetera, if you take a look at the third bullet, for instance, at 3.5 gigahertz, which is mid-band, you're talking about 1 million base stations roughly. As you go up to 28 gigahertz in the millimeter wave, the estimate is around 13 million base stations. And then you've got to add all the indoor locations on top of that, which is millions of more base stations. So thinking of it in that terms, there's a little bit of an exhaust in terms of the fiber backhaul, particularly when we compare ourselves to other countries that have laid fiber almost as a utility basis. Both the availability and cost of fiber in the United States is a little bit lower, and this is something that needs to be looked at as we move forward into 6G. So the real recommendation here is, without addressing these sort of XHAul requirements, it's going to be tough for the US to maintain leadership, especially in 6G. Next slide. Okay, so as we get into some of these potential focus areas, these are not firmed up yet, but they're open for discussion. We're moving down the path on several key areas. Next. So the first one, spectrum. Obviously, there's a need for a mix of licensed, shared, unlicensed. And one of the things our working group is, one, we applaud the FCC for their proactive spectrum policy, especially the recent opening, or at least the expected opening in NPRM related to 3.45 to 3.55 for licensed use. Also additional use options in the 3.1 to 3.45. Dana Deasy, the CIO of the DoD, just issued a request yesterday publicly for dynamic spectrum sharing, which signals, a real need and desire to open up both private and military use of that spectrum. So these are really, I would say, hot topics of the day, and the working group is going to focus on these in the last semester here. So the real key is considering shared spectrum where exclusive is not practical. What that would look like in terms of a data intensive model, and taking another deep dive on the SAS system as well. We've had a number of speakers over the summer as well as in the spring. What's the future of sharing? Is there a possibility to look at smaller geographies? For instance, CBRS was at the county level. Interference related issues, we're probably going to leave that to Kevin and Tom's group, but it's a key part of this overall issue related to spectrum sharing. Also, how about sharing via non-exclusive licenses, an area we'll investigate? Focus as well on spectrum efficiency. I think there's a number of people in the working group that feel that there's much more we can get out of spectral efficiency. And then the leadership role the US plays here with novel approaches. And we'll look at other spectrum exploration as well, for instance, beyond 7 gigahertz, and a couple other bands we've started to look at. Next slide. So another top area that's starting to emerge, and everyone's still in the process of deploying 5G, but the framing for 6G is starting to get, I would say, stronger and stronger. So what we're looking at as a potential recommendation is the FCC promoting the creation of a national roadmap, and that would encourage industry engagement, R&D standards. Somebody like Addis potentially could take a leadership role here to organize that for the industry. I think we can see, if you look in the rearview mirror, what happened with 5G. We really didn't have, I would say, per se, a national roadmap, and probably some lessons learned there that we could apply to 6G. Also, key 6G areas that need attention, again, spectrum. What's going to be available? Are we really going to focus solely on millimeter wave and terahertz? Is terahertz ready for prime time? Architecture, further densification clearly is going to create that fiber backhaul issue and challenge that we talked about in the previous slide. And then there's some research the FCC could support related to high frequency on that terahertz, as I mentioned. Multi-network or service convergence, at least from a service provider or operator perspective, can drive more efficiency. So, part of this would be the FCC encouraging application services. This is clearly an area that the U.S. leadership has a history of leading. And then FCC bolstering U.S. competitiveness just by encouraging that open, innovative environment related to development in the ecosystem. Next slide. As we look at IoT, we've still got some work to do here, clearly, in terms of some of the verticals to look at. But the FCC should consider private spectrum tied to IoT enterprise captured spaces type environments. And these are needs really specifically for limited geographic areas. There's a quote on the slide, for instance, from Bosch. It states, "We need private spectrum for control, economics, and latency." And they were pretty strong on the point in terms of both control and operation of that network. The U.S. could potentially have an economic disadvantage as well in terms of new manufacturing being developed here without that sort of spectrum compared to other countries. It's yet to be seen how strong that takes off. Germany's already, with BNetza, is fairly successful on 3.7 to 3.8. They're now moving and exploring millimeter wave as well for private spectrum use. So there's both midband and millimeter wave that, and there's some trade-offs. We put together a brief chart. We'll take a deeper dive and probably map some of the verticals to that and the different use cases as we move forward. The key really is, providing some sort of a reuse capability. The real focus is on high reuse. For instance, if you think about an industrial park, you really don't want to have one member in that industrial park be able to get spectrum and the rest not, which could be the challenge with something in midband. So shielding, limiting parameter emissions, things like that are all what we're going to focus on this last quarter, and how to optimize that use of spectrum. As I mentioned, we've got a couple verticals that are work in progress, transportation, medical, we're going to explore more. And what's really interesting too, although Brian gave the update on some of the 3GPP efforts, Standards is looking at how to make IoT more affordable. There's an effort in Release 17 called REDCap that really focuses on lowering the cost of mid-level IoT device needs, as well as the cost and battery life, things like that. So we expect a lot to come out of that in terms of driving IoT. Next slide. Potential areas of recommendation related to O-RAN. And again, this one's kind of interesting because clearly the FCC has really encouraged and supported this. The FCC we don't see the FCC really engaging in something like O-RAN Alliance or Coalition. But they do have sort of the bully pulpit they can use in terms of supporting Open RAN R&D, supporting interoperability, which is one of the challenges, such events like PlugFest, for instance, as well as looking at how to even promote this faster by leveraging enterprise and IoT verticals to adopt it. I just want to make the point, a lot of people look at Open RAN as like a CapEx savings and efficiency, but it's so much more. If you remember that first slide I started with, there's so many more capabilities being driven out of this. Unfortunately, I should say unfortunately a little bit, there was a interesting Open RAN webinar that was hosted by the FCC last Monday. It was a great webinar, great speakers. But the unfortunate part was some people were predicting fairly low adoption, even through 2025. So I think that's one of the real focus areas is how do we speed that up? How do we encourage greater adoption? Next slide. This is I believe the last slide. This is a work in progress. There's a couple big events taking place in the next month related to 5G security. There's also CESRIC that's got a couple working groups focused in this area. One specifically we're going to coordinate with. The industry is also considering zero trust models. There's a lot of work in standards. But jamming and spoofing are issues that are real. Just last week, somebody forwarded an email within the working group. You can literally buy one of these jamming devices for $8. It's incredible how cheap it is. And the kind of harm it can do. So I think these are all areas we need to take a deeper look at. Another area as well related to this is that power reliability and backup. In general, this has been solved by industry. We're going to take a look at it though, just to see if there's anything from a technical perspective to further explore or recommend. We did look at this in the past. So anyway, there's more work to be done here on security, and we expect to be able to wrap this up by December as well. Next. So that's it. We are open to feedback, input, questions, direction, etc.
Great job. You actually, I will admit, you surprised me. Yeah, got it, Russ. Nice hat. The glasses are great too.
It's all about the safety.
Brian, it's amazing your partnership with this guy. All right.
We were the last session. We gotta liven it up here. I mean, I think the after lunch slot is clearly the challenging slot.
All right. So we've got a question, or at least it flipped on and off. Lynn, did you have a comment?
Yeah, I was going to say, hey, Brian, on 3GPP, you're talking about, needing more folks to, in a sense, be involved on 3GPP to help as far as on voting. How hard is it for the U.S. to start getting more companies involved as far as across the United States, either the smaller companies or even quite a few other companies that are more from a technology side that could benefit as far as from this to go ahead and help drive that? Have we thought anything about that, or what should we consider?
Yeah, well, actually, Addis is thinking about that right now. It's certainly one of the challenges, and there's 2 points to make there. One is to get smaller companies engaged. Many of them can't send somebody over to meetings that are held globally. So this is an opportunity to get them engaged, while we're still in this virtual environment and boost the numbers up. There's also regional coordination. Even if we can get the smaller companies to participate, join 3GPP through ADIS, they can still help develop and co-source contributions for North American positions. And I think that's another avenue we need to explore. And the third one, and this one may be a little sensitive, is we need to make sure that companies that are North American based or have a heavy presence in North America actually participate in 3GPP through North America, through ADIS as the North American partner, rather than one of the others. And that's, again, an issue that ADIS is looking at and making sure that we address on a global scale as well.
Okay, thanks.
Kevin, Letty has one that you might want to just express it for our 2 co-chairs, because I think it's a very good comment that you put in on the chat.
Yeah, let me see if my audio is good enough to ask a question.
Yeah, no, it's good.
But the question is, okay, whether the lack of adoption of O-RAN is a function of the brownfield backward compatibility issues you were pointing out, or is there more to it than that?
Brian, you want to take that one first?
Yeah, I think you're right, Kevin. It is more a function of the brownfield backward compatibility problems as mentioned. Again, I don't think there's a whole lot more to that. I think, as the O-RAN Alliance develops more specifications and more vendors come on board to develop toward those specifications, certainly we'll see an increase in the deployments. Russ, more to add?
Yeah, I was just going to say, even from the webinar the FCC hosted, there was this big discussion on green versus brown and, how to get this, much more adoption in terms of supporting legacy networks. So, I think it's one of those areas. It was also brought up that O-RAN is disaggregating. It's sort of like the last area to be disaggregated almost. It's like everything else in compute, in cloud, all these other services have been disaggregated, and now telco is being disaggregated. So these things don't happen overnight, but I would say it's happening fairly rapidly. Just the massive number of interests, there's over 200 members in O-RAN Alliance. There's over 56 members in the coalition. So, I think it's going to start to speed up. The comment that concerned me was 10% adoption by 2025. That just seems really low. So I think that's an area that industry needs to focus on making better.
And the only other thing I would comment on is that there is still a maturity issue as well, and natural inertia of if it ain't broke, don't fix it kind of thing. So that would be the other items.
Thanks.
Any other comments? Okay, Kevin, go ahead.
Yes. So for Russ and Brian, I couldn't help noticing when you guys talked about Rakuten, Russ, you were talking about all the savings and things they've claimed and from O-RAN, but Brian, your slide indicated that they weren't O-RAN compatible. So just wanted to get clarity on that. I thought they were O-RAN, but can you clarify that contradiction?
I don't think I have a clarification at this point. That's probably something we're going to have to go back and look at, Kevin.
Okay. I'll have to take a look at the slide. I think the difference is whether they were Open RAN or O-RAN Alliance specific to that, what's been defined by that, standards organization. I think they were so early, they may not have fit into that compliance, but we can dig into that, Kevin, and get back to you.
Yeah, this is Jack. I'm pretty active in ORAN. I can answer that partially at least. There are parts of the Rakuten architecture that use the 7.2 Open Front Hall from ORAN. They also use some small cell stuff from that Qualcomm is helping to provide. But they're sort of a late entrant, I would say, to the ORAN alliance itself. I mean, they've only just joined within the last couple of weeks. They've been relying more on their vendors to sort of represent them in that forum. But I think you'll see more ORAN components going into the Rakuten network over time.
Yeah, just a note on that graph, by the way, I think it shows they were also 4G.
Right.
But we were in the process of trying to get that updated because there's been announcements that's migrating to 5G, which is expected to be done in the next month or so.
Yeah, I think Tom has additional from the chat window. Tom?
Yeah, thanks. Based on my research of what's going on, the Rakuten initially launched, so they are a greenfield operator. They won spectrum at the same time that the other three operators won. So they're a new entrant. They initially launched with an ORAN 4G network back in the spring, and then since have been expanding that network. And then they plan, according to the latest announcements, they plan to launch a 5G ORAN network of several thousand base stations next month. So, or maybe later this month. So we'll see. Stay tuned. That's why I didn't say 5G at the time that the slide was put together earlier this week.
It is a dynamic environment, so.
Yeah, it is. It is.
And it's really the exciting part of, and maybe why we're all here, because that was last week's chart. I mean, this is a whole week. So very good. Well, I think there are no more hands up, and the time is such that we probably should call it for today on the presentations. But I really do give kudos to each of you for outstanding presentations and covering a vast amount of materials. So I think we've really got more than our money's worth by spending the time engaged, and even some of us that are actively involved in some of the working groups. As it comes together in the presentation, in the meeting, it seems like there's even more there than you remember from the working group activities themselves. So very, very good. Let me shift now, and Ron Rapazzi, do you have any observations, conclusions from your observation of today?
Thank you, Dennis. A very quick observation. I'm very pleased with how far things have come since the last quarterly meeting back in June. Again, a lot of effort went into this, and great credit to the working group chairs and the FCC liaisons and all the participants in the working groups to get us to the point where we've got some very good material here to work with as we come into the closing cycle of the TAC in the December timeframe. So great work, everyone. And I appreciate all the hard work that's going into coming up with these recommendations.
Manisha, any observations, comments, guidance from you?
Just to add to what Ron said, as I mentioned, I try to dial into as many of these meetings as I can, and it's always been very educational, great speakers, great progress, great insights on all of the topics that you guys have been tasked with. So look forward to some really nice, actionable recommendations in a few months.
And you were one of those great speakers, so appreciation.
Oh. No, I didn't mean to pat myself on the back here.
She certainly was.
But it was highlighted, so kudos for contributing as well. Martin, anything from you as the deputy designated federal officer?
Nothing here from me, thank you.
And we'll turn things to our designated federal officer, Michael. Closing comments, observations, directions from you.
Yeah. Thank you, Dennis, and thanks everyone. This has been a great meeting. One of the best online meetings with all everybody's faces on. This is great. And also, I do observe that different working groups are at different stages in terms of providing the final recommendations. And the next tech meeting is on December 1st, which means that we only have about 2 months with the Thanksgiving in the middle. And given that a couple of weeks of a lead time to preparing the final presentation material, effectively we have about 6 weeks before we will kind of draw the final conclusions. So I'd like to recommend all of the working chairs start looking into and balancing the resources in terms of exploring additional topics and territories versus kind of wrapping up some of the conversations you're having and tie up some of the loose ends and start kind of farming down on the recommendations and try to bring that up to the working group so that people can have a thorough review of the recommendations and be able to have something firm for the commission to review in December. With that, I think that's all I have to, all I had on my bucket. Back to you, Dennis.
Okay, just to add on to what Michael's now said, we're now into the sprint part of the year because this is the short quarter because of both Thanksgiving being in the middle of it and the fact that this year, even earlier than in past years, our meeting is on the 1st of December. Usually it's at least on the 6th or 7th, but it's not, with this being later in the month of September than normal and the December meeting being earlier, it really is a short quarter. It's really 2/3 of a quarter, and the extra review time added to it says that we really got to hustle to get to the end point. But I think you've laid a really strong foundation for that sprint at this point. You're leading the race, to continue the analogy. You just got to kick it in to, to conclude and to finish well. On top of those all-important actionable recommendations, and I think we've got the makings of some really solid actionable recommendations, and I'm somewhat intrigued with where some of these can be taken to really move the ball forward in a significant way. But on top of those, we already had one suggestion, but please be thinking of next year's topics, be it within the context of the existing working groups, or it's time to quiesce your own working group, the one that you're involved in, and in Phoenix fashion, out of the ashes, create a new working group that would be focused on an area that had been raised within your working group, or potentially a brand new area. And that's where we seem to go with our working groups year by year. The Phoenix analogy is an apt one because we decide to dissolve a working group because we've carried it about as far as we can with the charter that had been established. But there have been foundation elements laid for the next working group out of the working group that was just completed. So please be thinking about those topics, and brand new topics are certainly acceptable too. Ones that are things that you've observed that we're just not paying enough attention to, and that you'd recommend that we put our focus on for the coming year. So with that, let me add my thanks as well to the chairs, the co-chairs. You've done an outstanding job in organizing and arraying your groups, and there is extra effort for being a chair. I do know that from experience, but it really does come down to the chairs. But there are also subgroup chairs that you've established, sometimes in fleeting ways, but thanks to them as well. But thanks to the TAC in general, because it's been a very active group, and part of the evidence of that is the number of people present for this meeting and the active involvement with the group. And it's a good group. It's really just qualitatively, I enjoy working with each of you, and that's a very positive part of this whole endeavor that we're involved in. Beyond the TAC members, we really have had, and it's already been highlighted, some outstanding subject matter experts and speakers, sometimes from the TAC itself, but very often some of the world's top speakers that, in part because of COVID, are sitting at home and are more available than they otherwise might be. And we've collectively been able to take advantage of that fact in a wonderful way. The list of speakers that's been presented today are really world-class individuals. So it's we've often joked about that we should be charging admission and make this a money-making proposition for the FCC to enable people to come and listen to the speakers that we have at the various TAC working group meetings. But it really is a special part of the TAC that we have the opportunity to hear from such distinguished people from global standpoint who have worked so deeply in the areas that are of interest to us. Then finally need to recognize from the larger group, the liaisons. The liaisons, we have a large group of liaisons this year and very active group of liaisons and really contributing significantly, in some cases, liaisons themselves also presenting to the group. And that's been terrific, providing guidance, providing clarity when it's needed, and occasionally advising the working groups when they're beginning to get off into areas that maybe are outside the scope of what should be covered within the group. So terrific job done by them. And then finally recognize Ron and Manisha and Martin and most especially Michael for the energies and efforts that they provide in giving us the direction and envelope and being the sponges that are absorbing the information along with the liaisons clearly and infusing that information into the FCC, because that's one of the important byproducts of our endeavors. We really, with those great speakers, they're not just for the TAC members, there are also for the liaisons who are able to take that information and use it in the day-to-day work of the commission. So with that, unless there are any final comments from anyone, don't see any hands raised, but kudos to all of you, and we will surely see you in various working group meetings between now and then, but see you on December 1st in the glass tube in front here. But thank you again for all that you've done.
And thank you for your leadership.
Thank you, Dennis.
Thank you.
Thanks,
Thank
Dennis.
you all. Thank you all.
Thank you all.
Thank you.